9. Ignition sequence.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
1, 0, and liftoff.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
And good morning from Mission Control Houston, and welcome to today's International Space Station update. Joining us here inside of the flight control room at the Johnson Space Center in Houston, Texas, looking over as the Orbit 2 team is monitoring all of these systems on board the orbiting laboratory. Today's team is being led by veteran flight director Paul Dye, and joining him at the Capcom position is Anna Fisher. She'll be serving as the communication link between all of our teams down here in the ground and the astronauts up in space. Those astronauts right now are the crew of Expedition 34. They're being led by NASA astronaut Kevin Ford, and he is joined by 3 Russian cosmonauts, 1 Canadian, and 1 fellow NASA astronaut, Kevin Ford there in the front row on the left. Behind him, Russian cosmonauts Oleg Novitsky and Evgeny Tarelkin, who joined with Ford on board the International Space Station back in October. And then there on the right, we have our 3 newest station crew members, Russian cosmonaut Roman Romanenko, Canadian astronaut Chris Hadfield, and NASA astronaut Tom Marshburn. Very busy day as work is in full swing on board the International Space Station. Starting off with Commander Kevin Ford, who a little bit earlier this morning was performing a monthly periodic fitness evaluation. He was doing that on the station's CVIS device, which is the cycle ergometer with isolation stabilization. It's one of the stationary cycle bikes on board that is used for exercise by these astronauts, doing that fitness evaluation as they constantly monitor their health during their 6-month increments on board the station. Aside from that, Commander Ford was working on the combustion integrated rack, doing some hardware gather for some upcoming experiments. And following that, and a little bit later in this hour, he'll be doing a ham radio pass using a traditional ham radio, much like those found on the ground down here, talking to some participants at the Missoula Family YMCA in Missoula, Montana. Meanwhile, Russian cosmonaut Oleg Novitsky was emptying out the soft tank over in the Russian portion of the International Space Station. He was also working to open up some of the holes in the partitions near the Russian service module, also known as Zvezda, working to run a few cables for the eventual mini laboratory module's integration with the rest of the station structure. His colleague, Russian cosmonaut Evgeny Tarelkin, was doing some cleaning work throughout the Russian segment today, cleaning off some of the panel vent screens throughout the air revitalization system inside of the station systems, also cleaning out some of the dust filters and replacing those inside of the mini research module 1, also known as Rosviet, where the Soyuz TMA-07M spacecraft is currently docked. They'll also be doing a few routine replacements on the Russian toilet system. Our 3rd Russian cosmonaut, Roman Romanenko, again, who just joined the station crew back in December, is working on the plasma crystal experiment today. It's a fairly complex look into studying the growth of plasma dust structures in zero gravity. This study also looks at particle cloud behavior and internal flow structures inside of these plasma dust crystals. He'll also be joining with Evgeny Tarelkin in their ongoing efforts to make a documentary about life on board the International Space Station being done for Russian agencies. Our Canadian astronaut Chris Hadfield was in his 2nd day of collecting biological samples for the Human Research Facility, taking blood and urine samples and then storing them in one of the cryogenic freezers on board the International Space Station. He'll also be running the InSpace 3 experiment. InSpace, a fairly long acronym standing for Investigating the Structure of Paramagnetic Aggregates from Colloidal Emulsions. This another fairly complex study taking advantage of that microgravity environment, looking to obtain data on fluids that contain ellipsoid-shaped particles that then change their physical properties of the fluids that they're in response to magnetic fields. Then our final Expedition 34 crew member Tom Marshburn, another NASA astronaut, was working with the environmental health system on board the station, setting up some acoustic dosimeters, which measure noise loads throughout the station structure. He was also working in the internal thermal control system, doing an install of a maintenance canister.
787 Dreamliner was designed to wow passengers seeking a truly unique flying experience. It is huge, but the aircraft has been bedeviled by problems since its launch. Today, Japan's All Nippon Airlines cancelled a flight due to a brake problem on its Dreamliner. Maggie Lake joining me now from New York City to discuss all of this. Yeah, I mean, making passengers nervous, I should imagine.
Yeah, I would imagine so, Michael. Not a good string of headlines coming out for Boeing this week. Let me tell you what Boeing's saying about it. Really not that much, because this is an investigation that they're in the midst of conducting, so they don't want to get into too many details about it. They are working closely with the National Transportation Safety Board, as well as the individual airlines and government agencies. But interestingly, one thing they said is that nothing we've seen in this case indicates a relationship to any previous 787 power system events. This isn't the first problem they've had, which is why it's getting people a little nervous. But aviation experts, safety experts, former regulators all say, even though it's sort of uncomfortable, the headlines, this is not out of the ordinary for the type of problems you'd expect to see with a new aircraft. These are incredibly complicated machines. And in fact, if you look at Airbus, when they first launched their A380, they also had some early problems. So not that uncommon still. As you say, I'm not sure that's very comforting if you're a passenger. And let's go ahead and let the people who are especially frequent flyers out there know some of the airlines. 49 of these are in operation, these aircraft, right now. I think we have a screen with the different airlines that are currently using them. All Nippon Airways, by far the most, 17. Japan Airlines, 7. United Airlines, 6. The rest have 1 or 2 in operation. But they're expected to be, there are 800 that are ordered. So the reality, Michael, is that in the very near future, most of us will be stepping on to one of these airplanes. Boeing working very hard to try to resolve these issues. You can imagine the engineers at Boeing looking at some pretty big overtime here in the first few months of the year, Michael.
Yeah, I bet they are. You know, and of course, this was supposed to be Boeing's flagship, if you like. What's it mean, or potentially mean, for their bottom line?
Well, that's what it has investors concerned. This is going to be, you know, the key aircraft, one of the key aircraft for Boeing. You did see a hit to the stock. It's been a rough start to the week as these headlines were crossing. It was down about 4.5% all told between Monday and Tuesday's session. Today, however, as I'm looking now, it's recovering almost all of that. It's up about 3% this morning. That is because the sort of experts have weighed in and said this is within the norm of what it's expected. I think the bigger financial hit, Michael, is going to be the fact that they've got to now, of course, deploy all their staff in terms of fixing these problems we've seen. And the other thing is the promise of the 787 was that it was going to be able to do these long-haul flights using a lot less fuel. That's what the airlines were so excited about. They have not been approved for those long-haul flights now. They're not able to fly without being a certain distance away from a major airport that can facilitate an emergency landing if needed. Until they iron out these kinks, they won't get that approval. So if that is pushed off and you are an airline who paid for that, you can imagine that they're going to have to give them discounts until they get that approval. So that is maybe they're not going to be able to realize the financial gain of this airline until they get all those safety issues ironed out. So it's probably going to continue to dog them and hit them a little bit on the bottom line. But right now, investors seem to be satisfied from what they're hearing from Boeing and the airlines. None of the airlines, by the way, have canceled any of those orders yet, Michael.
Maggie Lake on top of things as always. Good to see you, Maggie. Thanks so much.
Die Bilder aus Australien zeigen eindrücklich, mit welcher Kraft die Feuer wüten. Innerhalb von Sekunden können sich die Flammen zu einem tödlichen Ring zusammenschließen. Hier erkennt ein Kameramann gerade noch rechtzeitig die Gefahr.
Let's go.
Ähnliches passierte auch diesen 5 Kindern. Ihre Mutter hatte sie bei den Großeltern abgegeben, um ihren Mann zu suchen. Kurz darauf werden Kinder und Großeltern vom Feuer eingeschlossen. Wir sahen Tornados aus Feuer, die auf uns zukamen, und als nächstes brannte alles um uns herum. Tim Holmes hat jetzt nur noch eine Wahl. Er schickt alle ins Wasser und sendet diese Fotos als Lebensbeweis an seine Tochter, die außerhalb des Feuerrings verzweifelt auf Nachrichten wartet. Ich wusste, meine Kinder und Eltern können sterben. 3 der Kinder können nicht schwimmen und müssen im Funkenregen über Wasser gehalten werden. Wir waren teilweise bis zum Kinn im Wasser, weil 3-4 Zentimeter über dem See die Luft voller giftigem Rauch war. Obwohl es so heiß war, haben wir trotzdem gefroren. Ich habe die ganze Zeit gebetet, so viel wie nie zuvor. Und meine Gebete wurden erhört. 3 Stunden dauert der Kampf ums Überleben für Kinder und Großeltern. Dann ist die Feuerwalze durch und der Großvater kann seine erschöpften Enkel wohlbehalten zu ihren Eltern zurückbringen.
So, und jetzt Wechsel nach Australien. Sie haben die Bilder, Sie sehen die Bilder jeden Tag, muss man sagen. Wir haben hier die Vorschau für die nächsten Tage, die Temperaturvorschau. Da sieht man, dass sich der Hitzeschwerpunkt in den Südosten mehr verlagert. 46 Grad, also richtig von Entspannung kann auch keine Rede sein. In den Küstenregionen ist das allerdings kein Thema. Aber es gab ja einen Temperaturrekord von 48,2 Grad in der Provinz South Australia Anfang der Woche. Und bei uns das Wärmste war lediglich 40,2 Grad im Hitzesommer 2003. Kaum Wolken in Sicht, nur dieser Sturm, der aber wahrscheinlich an Australien vorbeizieht. Das war's vom Wetter. Ihnen noch einen schönen Abend.
Muss man Mitleid haben mit Henrik Broder? Ich begrüße Sie, meine Damen und Herren. Ein Mann, der sich unwohl fühlt, sich wähnt in einem Land voller Antisemiten und Judenfeinden. Ein anderes Bild hält er offenbar nicht aus. Nichts, aber auch gar nichts darf normaler werden. Da stand immer Broders spitze Feder vor. Eine Waffe, sein Antisemitismusvorwurf, blieb haften. Warum ist er ein armer Mann? Weil es ihn bedrückt, hier zu leben. Er erzählte mir Anfang der 90er Jahre, in einem Jerusalemer Café, wie er versuchte wegzuziehen. Er ging auch, nahm mehrmals medienwirksam Abschied von Deutschland. Mal zog es ihn endgültig nach New York, dann die Traut nach Jerusalem und immer kam er wieder. Stellte sich zur Verfügung als Mühlstein der Vergangenheitsbewältigung. Und jetzt ist Schluss damit? Ist er mit seinen Anwürfen gegen Jakob Augstein zu weit gegangen? Broder hat überdreht. Eine Chronologie der Broder-Augstein-Debatte.
Er ist wieder da. Der Begriff, in dessen Namen schon viele an den Pranger gestellt wurden. Ist er Antisemit oder nicht? Die Debatte tobt. Was ist passiert? Jakob Augstein schreibt für Spiegel Online:
Das Feuer brennt in Libyen, im Sudan, im Jemen. Wem nützt solche Gewalt? Dieses Mal auch den US-Republikanern und der israelischen Regierung.
Daraufhin setzt das Simon Wiesenthal Center in Los Angeles Augstein auf die Liste der 10 schlimmsten Antisemiten, zusammen mit Ahmadinejad. Sofort bemüht sich der Spiegel um eine Aussprache mit dem Simon Wiesenthal Center. Doch die wollen nur reden, wenn Augstein sich entschuldigt. Erpressung? Der Zentralrat der Juden eilt Augstein zu Hilfe. Salomon Korn hält Augsteins Texte nicht für antisemitisch. Das Wiesenthal Center sei über die Verhältnisse in Deutschland nicht gut informiert. Dieter Graumann bescheinigt Augstein zwar das Fingerspitzengefühl eines Bulldozers, er sei auf der Liste aber fehl am Platz. Der Höhepunkt heute: Henrik M. Broder wettert gegen Salomon Korn.
Der stellvertretende Präsident des Zentralrates der Juden in Deutschland war in den vergangenen Monaten vor allem durch öffentliches Schweigen aufgefallen, während er sich der Pflege seiner Krawatten und Manschettenknöpfe widmete.
Und Broder legt zu Augstein nach:
Augstein dämonisiert Israel, so wie früher der einzelne Jude dämonisiert wurde, als Gefahr für den Weltfrieden und Verursacher von vielerlei Übel. Wenn das kritischer Journalismus ist, dann ist die Allgemeine Fleischerzeitung das Zentralorgan des Bundes Deutscher Vegetarier.
Stellen sich folgende Fragen. Wer entscheidet, was Antisemitismus ist? Wer entscheidet, wer Antisemit ist? Und warum sind sich darüber sogar Juden untereinander uneins?
Guten Abend, Herr Brumlik.
Guten Abend.
Herr Brumlik, was ist denn da los? Das Simon Wiesenthal Institut in Los Angeles kürt einen linksliberalen, israelkritischen deutschen Journalisten unter die Top 10 der schlimmsten Antisemiten, und Henrik Broder facht eine heftige Antisemitismusdebatte an.
Ich glaube, das hängt mit der allgemeinen Beunruhigung sowohl über den israelischen Wahlkampf, in dem ein Rechtsruck zu erwarten ist, als auch der Angst, dass es in diesem Frühjahr tatsächlich zu einer kriegerischen Auseinandersetzung zwischen Israel und dem Iran mit nicht absehbaren Folgen zusammen.
Ist es nicht auch eine sehr deutsche Diskussion? Also wenn man die heftige Reaktion der nicht-jüdischen deutschen Journalisten sich ansieht, also wo gesagt wird, wer Henrik Broder glaubt, der kann auch gleich einem Kannibalen die eigene Frau anvertrauen oder der spreche im Jargon der Nazis. Ist das nicht auch eine innerdeutsche Diskussion?
Das ist natürlich außerordentlich schrill. Da muss man sagen, dass Herr Broder gleichermaßen sich sehr schrill geäußert hat, wenn er etwa Herrn Augstein vorwirft, propagandistisch den nächsten Holocaust vorzubereiten. Das ist ebenso schrill. Ich neige dazu, darin eine gewisse Verselbstständigung auch von Publizisten zu sehen, die sich ja in den letzten Wochen und Monaten gegenseitig hochgeschaukelt haben.
Nun gibt es eine große Unsicherheit bei den Journalisten, aber ich glaube ganz grundsätzlich bei vielen Deutschen. Was ist antisemitisch? Was darf gesagt werden und wo wird die Grenze überschritten?
Also Antisemitismus ist Judenhass, ein Judenhass, der nicht nur religiös begründet ist. Das Simon-Wiesenthal-Center hat nach einer Definition des israelischen Politikers und ehemaligen sowjetischen Bürgerrechtlers Nathan Sharansky 3 Kriterien angelegt. Kritik an der Politik israelischer Regierungen ist antisemitisch, wenn sie einem doppelten Standard folgt, wenn sie den Staat Israel als solchen delegitimiert und wenn Juden oder der Staat dämonisiert werden. Und nun könnte man sich die verschiedenen Äußerungen, die Augstein in dem Kontext getan hat, daraufhin einmal betrachten. Es ist sicher sehr einseitig, wenn Augstein Grass darin zupflichtet, dass Israel den Weltfrieden gefährde, ohne zu erwähnen, dass das natürlich durch die iranische Atomrüstung ganz genauso der Fall ist. Mehr noch, wenn Augstein meint, dass Iran seine Atomwaffen entwickle, gewissermaßen aus Angst vor Israel. Das ist natürlich völliger Unsinn. Als nicht antisemitisch empfinde ich die Behauptung, dass es auch in Israel ultraorthodoxe Juden gäbe, die so genauso fanatisch seien wie islamische Fundamentalisten. Das hat es ohne jeden Zweifel gegeben. 1994 hat der jüdische Fundamentalist Baruch Goldstein in Hebron ein Massaker unter 29 arabischen Besuchern einer heiligen Stätte ausgelöst. Also das gibt es sicher. Augstein selbst hat mit einem gewissen Bedauern zurückgenommen, dass er Gaza als Lager bezeichnet hat. Das war in der Tat unangemessen. Und die letzte ihm vorgehaltene Behauptung lief darauf hinaus, dass die massive Bekämpfung von Unruhen in der arabisch-islamischen Welt oder dass vielmehr diese Unruhen selbst und ihre islamistische Aufladung letzten Endes nur Israel und den US-amerikanischen Republikanern nütze. Das kann man so sehen. Aber als Ausdruck von Judenhass würde ich das noch nicht bezeichnen.
Es ist also eine sehr komplizierte Sache offenbar, Herr Brumlik. Und der Zentralrat, also die höchsten Gremien haben sich ja darüber gebeugt, über die Artikel des Herrn Augstein und haben also abgewägt, so wie Sie das gerade gemacht haben. Ist es nicht? Wie viel ist es antisemitisch? Oder ist das also eine sehr komplizierte Lehre geworden in der Nachkriegszeit, in der es sehr wenig Antisemiten in der Journalie gibt, zu sagen, das ist ein bisschen antisemitisch oder das ist gar nicht antisemitisch?
Naja, also das Problem besteht darin, dass wir, wenn wir den Begriff Antisemitismus hören, natürlich sofort an die Gaskammern von Auschwitz denken. Dass es Leute gibt, die Juden nicht mögen, denen auch der jüdische Staat unsympathisch ist, ist überhaupt nicht zu bestreiten. Und es gibt sogar eine nicht geringe Anzahl von Deutschen, die nicht gerne mit Juden in einem Haus wohnen würden. Das Problem hierzulande ist diese enge Verbindung zur Ermordung 6 Millionen europäischer Juden durch die Nationalsozialisten und viele, viele ihrer Mitläufer in Deutschland, die übrigens in vielen Fällen gar keine besonderen Antisemiten gewesen sind. Da gibt es gar nicht so eine enge Verbindung.
Herr Brumlik, ich danke Ihnen sehr für dieses Gespräch. Vielen Dank.
Bitte.
Es ist ein bitterböser Scherz. Hurra, die U-Bahn ist fertig, spotten Kölner Postkarten, seit der U-Bahn-Bau das Kölner Stadtarchiv in Trümmer gelegt hat. Nur der Dom steht hier noch wie einst nach dem Krieg. Doch inzwischen fragen sich die Kölner, ob der nicht selbst in Gefahr ist, denn das ehrwürdige Gemäuer zittert. Immer, wenn die neue U-Bahn drunter durchrauscht und der Dompropst zittert mit.
Ich habe da so ein Trönchen in der Sakristei, wo ich auch immer böse gucken, wenn andere drauf sitzen. Das ist ein fester Holzstuhl, Sessel. Und da merkte ich plötzlich, wie der anfing zu zittern. Und dasselbe auch bei einer Messfeier in der Sakramentskapelle, als ich da auch saß. Dann kommt so ein Zittern in dem Stuhl, das man im Körper spürt. Die Geräusche habe ich erst später gehört.
Der Einsturz des Stadtarchivs 2009 beweist, Ängste sind berechtigt. Der Kölner Untergrund besteht aus dem lockeren Trümmerschutt des Krieges. Unter dem Dom wurden schon früher Straßen und Parkhäuser gebuddelt. Seit Dezember rollt zusätzlich die neue Bahn. Und so bestätigt die Erdbebenstation Bensberg die Sinneswahrnehmung des Dompropstes. Messpunkte im Dom melden tatsächlich Erschütterungen. Die Kölner Verkehrsbetriebe räumen das ganz unerschüttert ein. Ihre Konsequenz? Die U-Bahn darf unterm Dom nur noch Tempo 20 fahren statt Tempo 30. Das beruhigt nur bedingt.
Man weiß nicht, ob Schäden entstehen und welche Schäden entstehen. Und diese Unsicherheit macht natürlich Sorgen.
Eine kölsche Lösung spotten Nicht-Kölner bereits. Mal sehen, wie lange die trägt.
And good morning from Mission Control Houston and welcome to today's International Space Station update. The crew of Expedition 34 hard at work at a full day of quite a bit of maintenance and experiment work. Starting off with Commander Ford. He began his day doing a glove exchange inside of the station's biolab glove box. Just a routine replacement of those gloves that keep the astronauts safe while conducting experiments. Following that, he started getting some components ready for the annual removal and replacement work on the waste and hygiene compartment. He and Chris Hadfield will be working extensively on that today, removing some of the urine components. Aside from that, Ford is spending quite a bit of time right now over in the combustion integrated rack. He's replacing hardware for the multi-user droplet combustion apparatus. It's one of the combustion facilities on board the station for performing different controlled explosion and fire, and burning and suppression of solids experiments in a controlled environment, taking advantage of that microgravity. Moving on, our Russian cosmonaut Oleg Novitsky is performing the Russian bar experiment, which is an ongoing look into the selection and testing of different methods for tracking any potential depressurization on board the International Space Station. He was joined in that by fellow Russian cosmonaut Evgeny Turelkin. Aside from that, doing some maintenance ops on board the station, removing and replacing one of the overlay panels inside of the Russian service module. And meanwhile, Evgeny Turelkin again is giving Oleg Novitsky a hand with that bar experiment, looking for different means of depressurization and also lending a hand in replacing that overlay panel. He was also taking some photos of the ongoing plasma crystal experiment, which is a study of growth of plasma dust structures inside of zero gravity. That experiment was being run by our third Russian cosmonaut, Roman Romanenko. Again, that plasma crystal, a fairly complex look at studying the behavior of particle clouds and also the structure of different plasma dust crystals. Aside from that plasma crystal experiment, Romanenko is working inside of the 49 Progress vehicle today, removing some of the cargo loaded on, also transferring some trash and disposal items back in as well. Moving on, Canadian astronaut Chris Hadfield is spending quite a bit of time today over in that waste and hygiene compartment. They're doing a annual overhaul of all of the urine components inside. He'll be replacing the urine valve block and also a number of the urine lines and pressure sensors, and also the WHC's flush water tank empty pressure sensor. Aside from that WHC work, he was working with the reversible figures experiment, which looks to investigate whether the perception of different figures is affected while these astronauts are in that microgravity environment. And our final astronaut on board the station, NASA crew member Tom Marshburn, was continuing some work he did yesterday with the environmental health system, setting up some acoustic dosimeters. This looks to track and study the sound loads throughout the station to make sure that it's all within acceptable ranges for these astronauts on board. Then finally, he'll be working with the capillary flow experiment today. It's a fluid physics experiment looking to investigate how various fluids move up surfaces in microgravity. The results hoping to eventually improve current computer models that are used by designers down here on the ground as they continue to develop low-gravity fluid systems and could potentially improve the fluid transfer systems for both water and fuel on future spacecraft.
Good afternoon and welcome everybody to NASA's Kennedy Space Center in Florida. We wanted to take this opportunity now that the calendar has turned to 2013 to give you an update on the status of NASA's Commercial Crew Program, reviewing the accomplishments of 2012 and also providing a look ahead to what's to come in 2013. We've assembled a panel of experts here to provide this update today, and after they give you an update, we'll be happy to take questions from Kennedy Space Center as well as the Johnson Space Center phone bridge, and on Twitter with the hashtag AskNASA. So we'll go ahead and get things underway. I'd like to introduce our panel. To my left, Ed Mango, NASA's Commercial Crew Program Manager. And to Ed's left, Phil McAllister, NASA Commercial Spaceflight Development Director. Next is Rob Meyerson, Blue Origin President and Program Manager. John Mulholland, the Boeing Company Commercial Program Space Exploration Vice President and Program Manager. Mark Sarangelo, Sierra Nevada Corporation Vice President and Space Systems Chairman. And Garrett Reisman, SpaceX Commercial Crew Project Manager. Thank you all for joining us, and we'll get underway with Mr. Mango.
Hi, good afternoon, everyone, and thank you for taking the opportunity to let us tell you about our commercial crew activities over the last year and what we'll be doing in the future. See, we have a few things we do want to talk about. We want to update you on where the program is at today in our commercial crew program. Phil is going to be doing a lot of that. Also, we asked all the partners to come and join us today to talk about what they have accomplished in 2012. It has been an unbelievable year for the commercial crew program, and what they expect to accomplish in 2013 as we continue to progress towards human spaceflight transportation from the United States. And then I'll come back and talk about a new initiative that is going to be kicking off here in a few weeks called the Certification Products Contract. We awarded that back in December, and we'll be picking that up here in a few weeks. I'll talk about that. And I'll also talk about our planning for our final development and certification effort. So first, I'll turn it over to Phil, and he can talk about where we're at as an overall initiative.
Okay. Thanks, Ed. It's good to be back in Florida, and I'm going to be talking mostly about sort of the strategic aspect of our partnership. The partners down to my left, they're going to be talking to you more tactically about the things specifically that happened on their technical programs, and I'm sure that's what you're most interested in. But partnerships are very difficult. They're even difficult when you have two private sector entities, but in this case we have a public-private partnership, which even makes the challenges even greater in some cases. So NASA has put in place several strategies to ensure, or to at least help ensure, that the partnership would be successful. And I want to touch on several of those. Before I do want to stress the goal of the program. Everything kind of flows from that, so almost all of my presentations start with the goal, which for NASA is to facilitate the development of a crew transportation system capable of flying to low Earth orbit and to the International Space Station for a variety of customers. So we aren't doing the development, we are facilitating that development, and that's where the partnership comes into place, because NASA has some unique capabilities to help, and the partners bring their unique capabilities, and through the combination we hope to do this very quickly, very cost effectively, and very safely. So the aspects of the partnership that I'm going to touch on very quickly so we can get to the good stuff are the 7 items you see listed: financial investments, the quarterly reviews and milestones, the partner integration teams, technical interchange meetings, reimbursable Space Act agreements, data sharing, and requirements application. So let's go to the next slide. Obviously, the financial investment is the thing that gets the most attention. And the money is critical, obviously. To date, through four different activities, we have awarded approximately $1.5 billion to help get us to a U.S. commercial crew transportation system. Not all of this has been paid out. As you can see, a good portion of that is in the ICAP awards, which are going on for about another year and some change. And most recently, you can see we made a small award for the certification products contract. That's a key one that Ed is going to talk about there. But through these series of investments, quite a lot of money to start off with. Still got some more to go, but this represents a pretty sizable investment that we hope will enable our partners to bring these to bear more quickly. So the next area of the partnership is obviously the milestones. Next slide. The milestones are the formal mechanisms in the Space Act agreements themselves that allow NASA to assess our partner progress. You do not need to read the graphic. That's really just a representation of the schedule for the next year and a half. And you can see there's a lot of tick marks. You obviously don't need to read the tick marks, but there's a lot of them. Those tick marks represent either a milestone or a quarterly review. And the milestones are key because that's where the money gets paid out, right? These agreements, they're not grants, they are not loans, they are pay-for-performance milestones. So the partners only get paid when they show demonstrative progress towards developing their crew transportation system. And that's what's important for us. So this is a key area where the milestones allow us to ensure that the partners are making good progress, are making good use of our money, and that is the formal mechanism by which they are paid. In addition, we also have quarterly reviews, and that's more of a management activity that allows us and the Commercial Crew Program Management Team to assess, again, the partnership as a whole. It's great to get these individual milestones and see how they're going, but we need to take care and feed the partnership, and that's what the quarterlies allow us to do. We get together every 3 months, talk about their overall progress, has there been any changes, any problems that have cropped up, and allow us to really talk about the overall effort for each one of our partners. So that turns out to be a good activity as well. Next slide. You know, a lot of people, I believe, think partnerships are really just about mission statements and core competencies. They really aren't. They're really about relationships. And the partner integration teams are where those relationships really take hold. They're the face of the agreements. They are the ones sort of on the ground floor with our partners, working day to day on their efforts. We have part of the partner integration teams represent a multitude of disciplines. So that's what you see in the right-hand graphic. They represent engineering, health and medical, safety, ground system, launch systems, crew office. All those capabilities are available and accessible to the partners and on a more regular basis. They don't provide direction, but they are available to provide lessons learned and history and experience with our partners on a day-to-day basis. And the partners help us gain the insight that NASA feels it needs in order to assess how the partners are really doing. So they're kind of an independent check for us to really understand the nature of the system, how well these tests are being performed, how well our partners are progressing. So it's really a two-way street that the partners the partner integration teams help our companies, but also help NASA. Next slide. You know, when we need to do a deep dive on certain technical areas or issues, that's where we use technical interchange meetings. And these have turned out to be very productive, very positive aspects of the partnership. It's always good to exchange information on a day-to-day basis, but some of these issues that crop up can be very challenging, complicated, and for those you might want to get a bunch of people together. The partners come with their people. NASA brings some technical experts that are outside of the regular pit teams but may have specific information into a specific subject matter, and you can really make a lot of progress in 1 or 2 days. We have had dozens of these TIMs with our various partners, and they've covered everything from propulsion to avionics to ground systems, just about anything that is really can be difficult. We've probably had a TIM on, or maybe multiple TIMs on. So that's turned out to be, again, a good, positive, face-to-face exchange of information. Next slide. Reimbursable Space Act agreements, this is a real win-win in my opinion, where NASA has unique, underutilized infrastructure, whether that be facilities or personnel or equipment. We can make them available to our partners on a cost reimbursable basis. So the partners actually reimburse us for their direct costs associated with using our equipment. Maybe it's a test stand, maybe it's a wind tunnel or something like that, or maybe it's even our technology or our people who have a unique expertise and may not be fully utilized at that point. NASA has a lot of infrastructure. That's something that's got a lot of press these days. And this is a great way for our partners to not have to recreate all that infrastructure, and also allows us to more fully leverage some of the infrastructure that may not be used 100%. So this has been a real win-win. You can see as of this is just a snapshot of the number of agreements we have with all of our partners at the various centers. There's 28 now. There's been more that have that we've had and have been completed. So probably close to 50 agreements just among our commercial crew partners that have allowed them to leverage our capability and allowed NASA to make those capabilities and equipment available. So that's been a real positive, like I said, win-win in my opinion. Next to last, next slide, is data sharing. Data, that's sort of a catch-all term. It means reports, it means analyses, maybe a test result. We have a lot of data at NASA, from Apollo all the way through Shuttle, all the way to Constellation. A lot of data on human spaceflight, and we can make that available upon request from our partners. To date, our 4 partners, either through CCDev or CCICAP, have made over almost 1,000 requests for data, and we are accommodating those as best we can. It really helps the partners, obviously, because then they don't have to reinvent the wheel. They don't have to redo a test. It helps NASA because it saves us money. If our partners don't have to redo the test, it saves them money. It saves us money. It also helps the nation. The nation gets the benefit of NASA's investment multiple times, not just from what its original purpose was, but we get to sort of repurpose that information for our partners, again, so they don't have to reinvent the wheel, and we can do this in a more cost-effective fashion. I see this, again, as a real super win-win for both NASA and our partners. And then lastly, I won't go into too much detail because this is where Ed's going to talk mostly, is requirements application. We just awarded the certification products contract. For the first time, it gives us a formal mechanism by which we can apply these requirements, disposition them, and give feedback to our partners about how well their design meets our requirements, so that we can be ensured that we get what we want at the end of this partnership phase. And then just to wrap up, I hope I made it within 10 minutes. I didn't get the hook yet, so I guess I'm good. Just to wrap up, I do need to stress that the Commercial Crew Program and our efforts to low Earth orbit, including the International Space Station, are just one part of NASA's overall strategy. We obviously have a deep space exploration strategy. That the programs that are supporting those are the Space Launch System and the Orion Multipurpose Crew Vehicle. So we have a complementary dual strategy at NASA, letting the private sector take a little bit more responsibility for low Earth orbit and International Space Station cargo and crew resupply, while still NASA sort of retains its more traditional role in the deep space exploration part. And again, these are very complementary strategies. We couldn't do one without the other, in my opinion. And what we're talking about today is really just the low Earth orbit piece. So thank you, and I'll turn it over to Rob.
Okay, thank you, Phil. Before I start, I wanted to thank Ed Mango for the invitation to participate here, and also thank our integration team, our PIT team, led by Misty Snupkowski and Bill Hill. They've been an outstanding group of partners and helped lead us through our CCDev2 effort, so thank you to them. I'm going to talk about Blue Origin and our accomplishments under CCDev2, and if I can have my first slide, please. You know a little bit about Blue Origin. We've been around since the year 2000. We were founded by Jeff Bezos, the founder and CEO of Amazon.com. We've got a long-term vision of increasing the number of people who can fly into space, and with that long-term goal of making space safe and affordable for more people than it has been in the past. You'll hear about incremental development today. Our incremental development plan includes a focus on reusability. We believe reusability is the best way to get to low-cost access to space and allow you to gain the practice that you need with your vehicles and your fleet to roll those lessons learned from practice into improving your design and lowering the cost even further. We've baselined vertical landing because we believe that's a very scalable approach for going to orbital operations, and vertical landing allows us to recover and reuse our vehicles. And we're starting with suborbital, again, getting to these incremental development fashion, starting with suborbital to prove out the technologies for orbital flight, and then moving on to orbital. We've made significant investment to date. There's some photos on the right-hand side of the chart of our facilities in Kent, Washington, and out in far west Texas that we use for engineering, manufacturing, and development test. We operate the only privately owned launch site in the world, and we've used that for all of our flight demonstrations to date. We have, if you see in the upper right photo, we have our own engine test stand in Kent, where we did development on our own rocket engine, as well as test stands in West Texas that we've used for developing the engine that I'm going to talk about a little bit later today. Also in Kent, we have vehicle manufacturing and capabilities in the Kent facility. I want to leave you with on this chart, we're a strong and growing company. We're hiring. We are adding on manufacturing capability, and it's been a significant growth over the last several years. Let's go to the next chart, please. Again, this chart's titled Incremental Development, and that's the core of our development philosophy. Our suborbital program is in the flight testing stage. We first flew short hop flight tests of a reusable vehicle called Goddard back in 2006. There's a picture on the lower left, and there's videos on our website. And then in 2011 and 12, we started flying our New Shepard vehicle, starting with a vehicle we call PM2. Which we flew on several flights, got that up to Mach 1.2, and the development of our next vehicle in that series in that program is under development right now. In our crew capsule, which is part of the New Shepard program, we did our successful pad escape test in October. That's part of our CCDEV2 agreement, and that's something I'll show you a video about in a later chart. This program is providing lessons learned and practice so that we can develop a low-cost, safe and affordable orbital spaceflight system. And we began development of that on our CCDEV2 contract with our agreement with the System Requirements Review for the orbital space vehicle. And that review took place in May of this past year of 2012. The vehicle is a biconic. It's designed to transport between 4 and 7 astronauts up to the International Space Station, and it weighs about 22,000 pounds with the crew on board at launch. It's designed to fly on multiple launch vehicles, including our own orbital reusable launch vehicle, as well as the Atlas V, and United Launch Alliance was a partner with us under CCDEV2. We worked very closely with them. Our two-stage orbital launch vehicle has an expendable upper stage and a reusable first stage, and pictures of that are shown on the right-hand side of the chart. And shows a little bit to scale to give you an idea. We believe that the New Shepard system is a subscale version of what we've got under development for our orbital launch system, and that reusable first stage is a key part of that technology. As we've gone into CCDEV2, the decision to get into CCDEV 1 and 2 was combined with the significant private investment that came from Mr. Bezos. And the NASA co-funding, we felt, looking at this program that was rolling out a few years ago, was a way to significantly accelerate our efforts. So on the next chart, please, talk a little bit about our CCDEV 1 and 2 activities. Our CCDEV 1 agreement was a total of $3.7 million. In that period, we developed and demonstrated a composite pressure vessel. We did structural testing, both pressure testing and drop testing of that vehicle. And then we also did some development of our thrust vector control system for our escape system, which was later demonstrated under CCDEV2. Under CCDEV2, our Space Act agreement was for a total of $22 million. And there was 3 projects there. The space vehicle design maturation was to basically refine and develop the design for this biconic vehicle that will fly on top of multiple orbital launch vehicles. We did wind tunnel testing, we did aerodynamic analysis, we did propulsion definition, a lot of requirements work with Ed and his team. Very, very good partnership on that refined that vehicle so we can take it further to the next steps. The pad escape test was the final milestone in our escape system development project, pusher escape risk reduction project, and I'll talk about that on a separate chart. And then our reusable booster system engine risk reduction test resulted in a full power level test, 100% power level test of an all-new American rocket engine that uses liquid hydrogen as a fuel. So let's go to the next chart, please. We'll talk about this engine, this rocket engine development. We call it the BE-3. It's a 100,000-pound thrust engine. It fits in between where the RL-10 and the J2X are. It uses liquid oxygen, liquid hydrogen as its fuels. And like I said, this is the first all-new American engine that uses liquid hydrogen as a fuel since the RS-68 development. It is deep throttling. It's restartable, and it's fully reusable. And under CCDEV-2, we did testing of the thrust chamber at NASA Stennis Space Center, E1 complex. The Stennis team has been a fantastic partner on this, and we always intended to continue working with Stennis after the CCDEV-2 agreement ended, and our next entry into Stennis is going to be in the middle of February. We ran multiple tests over the full throttle range, going into the teens in terms of percent. And on up to full throttle, which is 100,000 pounds. And the result of this partnership was that we accelerated the development of that BE-3 engine by more than a year, because the facilities we've developed under private funding at our West Texas site are not set up to do these types of high-pressure testing. The facility at Stennis is a unique government asset. So getting back to what Phil was saying, access to these unique assets and these unique expertise is a significant benefit to companies like Blue Origin. While we were doing the testing on the TCA at Stennis, we were also testing the turbopumps, the liquid oxygen and liquid hydrogen turbopumps at our facility in West Texas. And now we have the engine fully put together, and the testing of that engine is underway at our facility in West Texas. This engine, I want to point out, is fully developed, designed and developed in-house at Blue Origin. We do the analysis, we do the design work, a lot of the fabrication, component testing, and then engine testing, of course. And I've talked a little bit about the development plan, but it's a pretty complex system, and there's quite a few other components to the engine development program. We're going to show a video of our test at Stennis. Before we roll the video, I just want to give you an idea of what you're going to see. You're going to see the engine, the thrust chamber fire from the side. When it ignites, it'll start out at the low throttle setting, and it'll step up in a variety of throttle settings up to full power. The total test duration is about 45 seconds. So if we can go roll the video, we can take a look at this. Again, we call this engine the BE-3. It's a liquid oxygen, liquid hydrogen engine, thrust chamber, and full power setting is 100,000 pounds. So, and it's turbopump fed in its final configuration. But of course, in these tests, it's being run using the pressure of the ground facility. I got to hand it to the Stennis team again. They've done a terrific job, and I think if you had them in the room here, I think what we learned from them and what they learned from us is how to work in a commercial manner, how to speed up development, how to look at those assumptions that you've made when doing things one way, and then looking at when another company comes in and how you can accelerate your progress. We significantly ramped up our rate of testing over the period of this test program, and now it's getting multiple tests a day has been a significant benefit to us. So if we can go to the next chart, please. I'm going to talk about our crew capsule escape system risk reduction project. In October 19th of 2012, we conducted a full end-to-end demonstration of a pad escape system that will be used on our New Shepard suborbital vehicle, but it demonstrates the technologies and the integration required for an orbital system. The escape system is a pusher, and it pushes the crew capsule from the back to a safe distance away from the vehicle in the event that you have a mishap on the launch pad. We think this escape system is analogous to the airbag in your car. It's always there. It's lightweight, it's simple and reliable, and it's something that if you don't use it on a mission, you can just turn around and fly your vehicle again and again with a minimum of inspection. The demonstration here demonstrated, it showed the escape motor firing. It demonstrated our thrust vector control system, which was developed in-house at Blue Origin. The Aerojet provides a solid rocket motor. We developed the thrust vector control system and the aft closure for the motor. The guidance and control, the parachute deployment, the landing, and the recovery. Like I mentioned, this test was conducted with our NASA partners on site at our West Texas launch site on October 19th. And it was the only powered flight test under CCDEV-2, so we're very proud of that accomplishment. There's a few pictures at the bottom of the chart, but I want to pull up the video. And before we start the video, I want to just kind of explain what you're going to see. The vehicle is mounted on top of what we call the booster simulator. So it's sitting on top of a structure that represents the upper end of the booster that it's going to be escaping from. That booster simulator is fully instrumented. It's with load cells, pressure, and thermal sensors, so that post-flight we could reconstruct the environments that the booster vehicle will see in an escape, in an in-flight escape, or a pad escape. The vehicle itself, of course, was instrumented. This is a flight structure. You'll notice it doesn't have windows. It also doesn't have seats or life support systems, and that's part of our incremental development program. We wanted to have a flight structure in place, but we wanted to fly this vehicle in this pad escape environment, measure the loads and performance, and then use what we've learned from that to roll into our next version of the design. So let's go ahead and roll the video, and you'll see what we did. And this video is available on our website as well.
1, escape.
Now the vehicle pulls significant accelerations on the escape. It reaches about 2,300 feet altitude above ground. The parachutes deploy and it comes back. It landed within 7 feet of our predicted touchdown point. The winds were light that day, but we still are proud of the accuracy of the predictions we were able to make. Following some stabilization, the main parachutes disreef, and the vehicle descends slowly under the three main parachutes and touches down in the desert.
300. 200.
It was a beautiful day, I might add. So.
100.
So I want to close up with the point. This has been a great commercial partnership. We brought money to the table, NASA brought money to the table, and we were able to do some things that are very useful, very effective, and help Blue to accelerate our progress. It's been a great relationship, and I'm happy to announce that we're working with NASA to extend our Space Act agreement in an unfunded manner, so that we can continue the relationship, continue to learn what we have from NASA, continue to allow them to learn from us, and that's something that we'll be working with them here in the coming weeks, and I'm very, very pleased about that. So, thank you.
All right, thank you, and thank you, Phil and Ed, and your entire team. It's an honor and certainly exciting to be part of this important new development effort. If we could go to my first slide, our focus on identifying and mitigating risks early in CCDEV-2 really ensured we could mature the design to the point that we could accomplish a successful PDR and transition strongly into CCICAP. Our focus was across all of our subsystems to make sure we identified key design and risk drivers, and then perform the analysis and risk reduction demonstration testing that we needed to successfully mature that design. If we're looking at structures and mechanisms, we manufactured 2 iterations of our pressurized crew module, and we're able to do proof and leak tests on it, and also material testing to make sure that the design properties on the as-formed material met all of our requirements. We conducted a number of composite material tests at higher temperatures just to make sure that the material would satisfy all requirements, and early micrometeoroid debris testing to help ensure that our thermal protection system design would satisfy all of our safety requirements. On the landing system, which is a combination of parachutes and landing airbags, we ran a number of 2 parachute drops and a large number of landing airbag drop tests just to make sure that that design was safe and robust in all types of landing environments. Propulsion system, we ran a number of single-engine propulsion tests. The service module that we have is a disposable service module that handles not only the launch abort propulsion, but also the on-orbit and entry propulsion, and ensuring that these legacy engines modified to our requirements would perform all the tasks early in the design cycle, really help buy down some development risks. And we also went out to Ames and the wind tunnel test and had a large number of runs and help us build up our aerodynamic database to make sure the vehicle that we're designing could withstand the loads and was also controllable in all flight regimes. On to the next test. Another big focus on our effort to integrate with the launch vehicle. One of the things we did early onto the next page was to bring in the emergency detection system that's being designed and built by United Launch Alliance for incorporation into the Atlas V launch vehicle, and run early testing on an EDS emulator integrated with our software and our flight computer to make sure very early in the software development process that the two systems were compatible or could talk to each other and would satisfy all requirements. We also ran a number of integrated tests between our flight software system and our autonomous rendezvous and docking system, which obviously is a critical piece of this development effort to make sure that those systems were compatible and would meet all requirements. And a large effort on identifying different options for our cockpit and then moving quickly at the end of CCDEV2 to finalize that cockpit design with a number of human factors tests in the cockpit to make sure that all of the panels were laid out correctly. We could satisfy not only normal mission operations but also anomalies that the crew could expect to encounter. So a lot of work, just making sure we identified those risks and were comfortable moving into CCI-CAP. Going to the next chart. The real focus of CCI-CAP is final design maturation and moving into a quality critical design review. And so our focus was laying out a plan that integrated key milestones across all of the different development segments, both spacecraft, the launch vehicle, obviously, which is critical to us, but also production and operations. So across this entire plan, we've got a number of very important and milestones that our team is working on to accomplish. In January of this year, we've got 2 milestones actually. In the next couple of weeks, we'll be releasing our first flight software iteration of our on-orbit configuration, and the team is in the lab now running tests on that, and it looks like that is moving along real well. And then later on this month, we'll also be conducting, actually next week, our landing and recovery and ground communication design review, just to make sure we have the plans and the equipment and the infrastructure we're going to need, not only to communicate from the ground, but also to safely recover and transport the capsule after it's landed. Looking at some of the others, we'll move very quickly into a preliminary design review with United Launch Alliance, one of our key partners on the launch vehicle adapter. That'll be the adapter plate between their launch vehicle and our capsule. We'll be going back and doing more wind tunnel tests. In fact, we've got 5 different wind tunnel test series between March and August of this year, just so that we make sure we have a healthy and robust aerodynamic database so that we can finalize all of our designs. We've got a dual-engine Centaur duct test that we've got scheduled later this year. The dual-engine Centaur actually has flown 140 successful missions, but not on the Atlas V, previous versions of the Atlas. And so we are going to do a number of component updates. And so that work is understood, but it's something that we want to go demonstrate. We'll have a number of engine test runs again with the Pratt & Whitney Rocketdyne designed service module propulsion system, just to make sure that the final design configuration of those engines will meet all requirements. We'll move in and with our partnership with Mission Operations Director at JSC, who is very integral to our team and adds a tremendous amount of expertise. We'll be doing a Mission Control Center interface demonstration test. moving on with some more production demonstrations. And then in December of this year, our multi-string demonstration of our flight software, which will be a very important milestone. All focused on, in this phase early on right now, we're really focusing on component PDRs, moving very quickly later this year into component CDRs and then into subsystem CDRs. Everything focused on making sure we properly and aggressively mature the design so that we can have a very robust critical design review at the end of this phase. It'll give us confidence that we can move in with very low risk into the qualification and flight demonstration phase. A lot of good work. The team's really excited, and the first 3 milestones we have accomplished. Moving on to the next page on schedule, which is very good. The first one coming into CCI CAP was the integrated system review. We had a number of systems that we had some open trades on that we needed to complete going through the preliminary design review. And it was really important to burn down all of those design trades before we moved into CCI CAP. Our team was able to do that, and that really let us snap that baseline design and move into to final design release and start producing those products that we need. The next thing we did, the next milestone, was a production design review. It was important for us early to make sure that we had the right plans, equipment, and infrastructure so that we could efficiently produce the design that we were coming up with. And so getting that early design review and that focus, making sure that the design that we were producing would be manufacturable efficiently was a real benefit, along with bringing in a lot of expertise from across Boeing, both the commercial airplane side and also some of the military and defense that have a lot of production experience, and making sure we're bringing in those best practices was good. Huge focus on safety, obviously, and having that phase 1 safety review completed early in the design process, again, so that you can use that safety analysis to make sure you help inform the design was really important. And the phase 1 safety review helped us identify all the hazards, the causes, and the controls, just to make sure that we were appropriately embedding safety in all of our designs. And then a lot of work, as I mentioned before, about making sure that we were addressing human factors and that our cockpit was laid out. It's really important to do that early so that we can snap that baseline design and move forward. And so the team was able to do that. On to the next chart. As I mentioned, a lot of focus this phase on making sure we get to final design release and mature the design. The teams, as they're heading to CDR, have a number of, again, risk reduction demonstration tests that they're going to need to get through their design cycle with high confidence. A real focus on making sure we're bringing an integrated system to the table. And so our partnership with some of our really important partners like ULA, Pratt & Whitney Rocketdyne on the propulsion, Aerojet on crew module propulsion, an integrated team focus, making sure we're moving forward. Again, our partnership with Mission Operations, I can't understate that bringing in that legacy experience really helped drive down a significant amount of risk that you would have trying to stand up that capability. So getting that expertise in was critical. And then, one of our real focuses and one of the real benefits has been our partnership with Space Florida and the ability to partner with them on the use of the old Orbiter Processing Facility 3 here at KSC. That partnership has been outstanding, and they've actually, as you can see on some of the pictures on the bottom left, have that building cleaned out now, and they're starting in on the modification process right now, and will be ready to hand over the keys to us this summer. So that's been outstanding to be able to make sure we're able to use not only the skilled resources here in Florida, but also some outstanding infrastructure. So that's been a real bonus for us, and the team's really excited to get in there and start using that. So I'd say, our team has really ramped seamlessly from the preliminary design phase into this final design phase. We're really excited about the work we've got on our plate and the progress we've made to date. Thank you.
Mark? Oh, sorry. Mike, sure, you're finished. You didn't have a video. Hi, everyone. I'm Mark Sarangelo from Sierra Nevada, and I'm really thrilled to be here today to give you an update on what we've been doing with our program. And we have had a major amount of success over the last couple of years, and we're very fortunate to be part of this program and be part of the activity that's going on. I think it's one of the best-led programs that we've been involved with through our history. And we're celebrating our 25th anniversary in space this year and have now over 70 missions with NASA and over 420 missions to space in total. And I have to say that the development of this program really has been extraordinary, because not only has it been well run, but the new ground that we've been trying to cover and put together has been amazing. How much activity has to go on to get this program to be where it is. And I think, as you've heard from all of us, and you will hear from SpaceX in a few minutes, we are moving forward very rapidly, and I think it's a testament to where we are with the program. Our 2012 has been a wonderful year, and I think part of what we like to talk about here, besides the hardware, is the passion that's involved with this. We've been involved with developing our Dream Chaser vehicle now for over 10 years. And when you come see us and when you come be part of our experience, you can see the amount of people who are amazingly passionate. And I have, I believe, the best team in the industry behind this, coming from all over the country to become part of this journey. We've completed now over 20 milestones across our programs. We've been part of this from the very beginning with NASA. And those milestones have been a mixture of very technical and program element milestones with a lot of hardware. And it's part of our belief that hardware development can go side by side behind technical development and program management to make sure that everything gets moved along at the same kind of pace. During this past year, many milestones have been completed, and I'll go through a few of those. But I think as you see them, that really what stands out is that we've gone from being something that is conceptual to being something that is now a full flight size vehicle ready to start its flight tests. And in a very short period of time, that's, in my view, that's one of the greatest accomplishments we can do. If we go to the next slide, please. These accomplishments come from a number of different places, and I want to point out a couple of them, not just because of what they are, but because of what they represent. Our wind tunnel testing was done through the partnership and cooperation of both university. We did some work at Texas A&M, as well as NASA centers, where we did work both at Langley and Marshall. And it's our philosophy, and it's been from the very beginning, that this is a team effort. We now have over a dozen industrial companies involved, 3 universities and 7 NASA centers who are part of our program. And it's this collective group of very talented people, all who have the same kind of passion around moving forward a vehicle that really has made this very special for us. And the wind tunnel testing that we've done in all 3 of the areas really moved the design forward at a pace that we could never have done on our own. And we're very thankful for all our partners and the way that they've interacted with us. Next slide, please. I think when you do something like this, there's certainly a lot of excitement that comes in, but nothing more exciting than when you're actually starting to build the actual vehicle, and when you can put your hands on it and you can see how it comes and gets developed, and you can see it start flying. And this past year saw us developing what we call our ETA, or Engineering Test Article, where we've been able to put it together. And the first vehicle was done to do structural tests and loads tests on the vehicle, and the second vehicle was built to actually start its flight regime. Next slide, please. And we're very pleased to say that that structure was completed during the course of this year and began its early stage testing with a captive carry done in Colorado over Memorial Day weekend of this past year. This is the full-size vehicle, full regime of the vehicle. It's not fully outfitted for orbital flight, but to be able to go from concept to go back into the assembly hangar and see something being built is really extraordinary from my point of view. Next slide, please. And you can see pictures of this. We were very fortunate in Colorado to have some very good backdrops, and we could take advantage of them. And it was really pretty special because we actually did it over Memorial Day weekend. And what you see below this is the University of Colorado in Boulder, where Scott Carpenter lives, and it happened to also be the 50th anniversary of his flight. So we were able to really have a nice tie-in for what we were trying to accomplish. Next slide, please. Other highlights from the year, we did a Buffett test model. We developed and started advancing our Eclipse systems. We started doing our simulated for docking, and now have a simulator up and running, and soon to have a more advanced simulator completed. And we've did some very structural and important elements like landing gear and testing. Next slide. I think one of the things that gets lost in this program is how important it is to our country and how important it is to our industry. We're participants in the rollout of Atlantis here as it went through the center in Kennedy. And because in many ways we feel we're the emotional successor to what has gone on with the shuttle, we thank the program leadership a lot, we thank our partnerships a lot, but sometimes what we don't do is thank all the thousands of people in NASA who have worked tirelessly over the years throughout the moon programs and before that, and certainly through the 135 shuttle missions. And we wanted to say thank you to that, and because we feel we've picked up that not only the knowledge from that program, but the emotion behind that program. And one of the things we saw as we came through for the Atlantis is how many people came up to us. And how many people, we had lines going on, that people just waited in line to sit and just talk to us. And we feel certainly special about that. But I think what that says is how important this program is to our country and to our industry. People want to believe, they want to feel that exploration means something. And I think as we all have seen, that we feel that emotion is important to this country. The number of students and kids that came up to us who are going to be the next generation of people sitting on a podium like this, they get inspired by this as we got inspired by it. And I can't say how important that is to our country and to our program. Next slide, please. Our growth has been significant. We've hired many people from all over the industry. People who are really talented people. We are expanding our facilities. We're putting on a new dedicated assembly and design and engineering center that will be standing up in the next couple of months. We'll be adding probably up towards 100 new people throughout the country in this next year in 2013. We have 7 NASA centers who are engaged with us, as I said, multiple universities and a number of very significant partners that are part of the program. Next slide. In 2013, we're going to see we think some very major advances. We're going to complete our integrated system and design review. We completed that as part of the CCI CAP milestone. Actually have completed first 2 milestones under the CCI CAP program and are about to, in the next 2 weeks, to complete our 3rd. So that program is moving very quickly and very positively forward. I think most evident will be the fact that we're going to start our actual flight test program this year. Our flight vehicle is now being finally assembled and will be moved out to Edwards Air Force Base, where the Dryden Flight Center, NASA Dryden, will be helping us do the work. And we think that's just the right thing to do in many ways. That the facility there has been the home of so many tests, including the shuttle test. And we're going to be picking that mantle up and starting our first flight tests here in the first quarter of this year with the vehicle. Autonomous flight tests will happen, and that will be a full drop, and a full autonomous flight. So things are moving very rapidly. Our motor testing is going on in our California facility, and we'll be doing continued rocket motor testing there. And we'll be doing things like our reaction control system and many other hardware activities. So it's going to be a very full year, full of milestones and full of very visible hardware milestones as well. Next. And as I close out in the last minute, we have a very short video, but I wanted to express our appreciation to the press as well. We talk a lot about what's going on. You guys put a lot of effort in here, but it's important that you get the story out that the human space flight is not dead in America. There are at least 4 companies represented here who are working very hard to make that happen in partnership with NASA. And as we go through our budget cycles, it's really important to be able to say for not a lot of money, we've made tremendous progress and are continuing to make tremendous progress. And I thank you for that. If you could run the video now. I'd like to turn it over to Garrett now from SpaceX.
Thanks, Mark. Thanks. So if I can start with my first slide. So about a year and a half ago, SpaceX started partnering with NASA to work on Crew. And this was really, really important to SpaceX for a number of reasons. First being that the company was founded with the sole intent or sole purpose of advancing the cause of human spaceflight. And so this is really what we're all about. And so having this opportunity to be part of the Commercial Crew program is very special to us. Second reason is that, you know, for well over a year now, since Atlantis came to wheel stop, the United States of America no longer has the capability to launch people into space. And that's something that that we are not happy about. I'd venture so far as to say that nobody sitting up here on this panel is happy about that. But we're very, very proud to be part of the group, the Commercial Crew program, that's going to do something about that and get Americans back into space. And at SpaceX, we feel a sense of urgency to get Americans back into space on safe and reliable transportation on American-made rockets. And so I'm very happy for that reason to be here today. So during the first program, CCDEV-2, we're in a bit of a unique position at SpaceX because we already have a rocket and a spacecraft that is traveling to the space station. In fact, we've gone back and forth to the space station now twice on cargo missions. So we took the approach in CCDEV-2 of figuring out, well, what do we have to do to modify this rocket and this spacecraft to not only carry cargo, but to carry people? Now, this wasn't that hard because from the very beginning, we intended to do this. And on our first cargo flight, that vehicle had windows, for example. That's a superficial example, but technically we had built into this vehicle the capability to meet human rating requirements from the very beginning. And so there were still some things we needed to do, technical challenges that we needed to overcome to get ready to carry people. So that's what we focused on in CCDEV-2. It was primarily the launch abort system, so we built a new engine, which we call the Super Draco. It's a 17,000-pound thrust hypergol engine, and we were going to use 8 of those to provide basically an ejection capability for the crew to take them to safety in the event that the Falcon 9 rocket is having a bad day. So we developed the engine, we developed a test stand to test the engine, and we developed all the related components. We also worked on all the other things you need to do that people need that cargo doesn't need. So we worked on seats, on spacesuits, on life control systems, how we're going to modify our launch pad, all those different things that we need to do for Crew. And finally, we did a bunch of homework, a bunch of analyses to make sure that our designs were heading in the right way. And last, we did a couple crew trials where we brought NASA astronauts in, had them sit in a prototype of the cabin of the Dragon and evaluate it for ergonomics and human factors. So we did all that in that 1 year, and we completed everything back in June of last year. So that's all done. And then we moved on, I'm sorry, in the next slide, there's some pretty pictures of some of those things that we did. You see a depiction of the interior of the cabin, what that's going to look like. We're going to have 2 rows of seating. It's going to be stadium seating. Upper row there is first class. The bottom row is that's the coach, I guess. So that's what it's going to look like on the inside. The picture of the rocket engine there is our Super Draco engine firing on our test stand that we built in just a few months in our facility in Texas. You see some of the modifications we have planned for the tower. In the middle picture on the bottom is some testing we were doing of our carbon dioxide scrubbing for the life support system. And finally, you see a picture of a prototype spacesuit that we worked on. So that was all done and finished back in June of last year. So moving on into CCI-CAP, which we're very proud to be a part of, we basically have 4 main focus areas for CCI-CAP. And this is what we're going to be working on for over another year. And that is to complete the integrated design, to complete the design of both the rocket, the spacecraft, the ground systems, the mission control, all that, to a critical design level, meaning that we're ready to start building and pretty soon flying. So completing through a critical design review is the first goal. Second thing is we're going to do a lot of hardware testing to reduce risk. We believe in testing hardware early and often at SpaceX, and we've already done a bunch of this, and we're going to do even more in the near future. We're focused during this whole period on crew safety. We know this is very, very, I can't stress how important that is. Having strapped into a rocket before, I could tell you that I have a personal, emotional reason why I want to build a vehicle that is safer than anything that's flown before by an order of magnitude. And finally, preparing for NASA certification, making sure that we're building a vehicle that is going to meet NASA's needs. So those are the 4 areas that we're focused on. On the next slide, I think I could tell you a little bit more about the detail. This is a whole bunch of different milestones up there, but these are all of our milestones in the space period that accomplish those 4 objectives. And we've already completed the first 4, and we're moving on. The 5th one is coming up in March. Our plan is to get to the point where we can fly to the ISS with a non-NASA crew by the end of 2015. Now that is if we successfully execute all of our base period milestones and our optional period milestones on schedule. And so far we're on schedule. Next slide. So in 2012, what we've done so far in CCI-CAP, we've completed these 4 milestones: a technical baseline review, a financial and a business review, a system requirements review, and then our most recent one, just before the holidays, we completed our preliminary design review for the ground systems and the ascent part of the flight regimes. So you see some pictures in there of some of those things that went into that preliminary design review. You see a picture of the new engines. We're upgrading the Falcon 9 rocket, and a big part of that upgrade is to be ready to carry crew. One of those things are new engines. That's a Merlin 1D. It finished its qualification testing, and we're moving ahead with that. The next step is to test 9 of them together in a stage. To the right, the picture you see there to the right is wind tunnel testing that we did at Langley, NASA Langley, in partnership with one of these reimbursable Space Act agreements, and we tested a new shape of the capsule to make sure that our modifications will work well as a cargo Dragon does for coming back through the atmosphere for entry and then ultimately for landing. Finally, you see some conceptual ideas of how we might do displays for the crew, how we would overlay data and video for, in this case, for proximity operations and docking. Next slide. So what we have coming up in 2013, we have a lot on our plate. We're going to be very, very busy. We have a pad abort test review where we're going to go through the test plan in detail for the pad abort test that we are doing at the end of the year. We're going to do a human certification review to make sure that we have a plan in place that will get us to a certified vehicle ready for NASA astronauts to take to the space station. We're doing an on-orbit and entry preliminary design review, so we did already the ground systems and ascent. Next step, we have a second preliminary design review to focus on orbit and entry. That's coming up this summer. Then we move on to the in-flight abort test review. That's the next big hardware test. And then we have a safety review focused on all those products that will go into detail about how we're going to accomplish that order of magnitude safety improvement over any previous vehicle. And then a flight review of our new upgraded Falcon 9 comes in November. And finally, we end the year on a really big high note, which is by doing a pad abort test right here behind us at KSC, where we're going to take this is not a demonstration test, this is a flight-like, full-scale pad abort test for certification as well as risk mitigation. We're going to take a Dragon as flight-like as possible, take it from our pad over at Cape Canaveral Air Force Station, and demonstrate our ability to get away from the Falcon 9 on the pad from 0 altitude and 0 airspeed if we're having a bad day on the pad. So that's what we have coming up in the next year. I want to give you a sneak peek into 2014, if we can show the next slide. So in 2014, we have 3 milestones that wrap up CCI-CAP base period. And in that period of time, we're going to do a qualification testing of the primary structure. We're going to stress it and bend it and hopefully not break it, but make sure it could take anything that it might get dished at it in flight. We're going to do the final critical design review and prove that we're ready to start manufacturing. And then finally, we're going to end this program by doing an in-flight abort test, meaning that we're going to take a Dragon, again, a flight-like Dragon, full size, stick it on top of a Falcon 9, launch it out of our launch pad right here, and at the worst possible moment, we're going to have that Dragon light up its Super Dracos and fly away and safely splash down into the Atlantic, demonstrating the capability to deliver the crew safely should the Falcon 9 be having a bad day. So in a nutshell, that's what we have planned for CCI-CAP. Again, we're very happy with this partnership that we have with NASA. We want to see it continue all the way so that in the near future we can get Americans back into space on American rockets.
Ed?
See, thanks. As you can tell from our partners, they have been extremely busy. And I think the partnership between NASA and each of these companies clearly shows that we have a very vibrant space industry in the United States, and the space industry wants to meet the goal of getting U.S. capability back into low Earth orbit. I have a few charts to talk about the big picture from the program standpoint and where we're headed, where we're at now, where we're headed. So if I can go to my first chart, this is a chart that kind of shows our program life cycle, and you can think about, well, what's a life cycle? From us program guys, we look at a life cycle from the time we begin a new thought to the time that we are actually executing the mission. And in this case, we really have two purposes of the commercial crew life cycle. One is for a public purpose, and one is also for a specific NASA purpose to get to ISS. You can see that in the yellow life cycle. All of our partners, all four of the folks here today, have all been part of this public purpose, either through CCDEV-1, CCDEV-2, and now into ICAP. You can see that a couple of them, three of them, are now continuing on into ICAP, and then some of those will then transition into the blue line, which is our NASA purpose, which is certification and services. So by doing this, we really are creating a capability for the nation to use. And as we create that capability, then NASA will become a customer of that service so that we can use this capability to move our flight crew and our astronauts to the International Space Station and continue on with the science of the International Space Station. Well, that's a nice pictorial. Now how do we actually make it work? And that's the next chart. We showed this chart back in August of last year, in which you said, here's our acquisition strategy overall for the program, for the commercial crew program. You can see all the partners here today talked about CCDEV-1 and 2 and ICAP, and that's the top portion. We also talked back in August, and I'll re-highlight again, that we have two phases under the certification phase, under the certification effort for our international, for an ISS crew transportation. Phase 1, which I'll talk about that in much more detail here in a minute, is the phase that we're just starting, and it'll be starting in about 2 weeks. We'll then transition to phase 2 in the spring, late spring of 2014. And that second phase I'll also talk about briefly today, and how that phase is really going to take us from all the work that has been done through the development in a partnership with our partners today and with any other new industry partners that would like to come join us to compete for the capability to go get certified for a NASA mission to the International Space Station. And that should be concluded sometime between 2015 and 2017 from an overall schedule standpoint of when we think we can get crew and a capability for services. And then we'll, of course, transition into services once we have a certified system. Today, I want to talk a little bit about the next chart, which is our certification products contract. When we awarded ICAP in August, we quickly turned around and said that we need a contract mechanism by which we can talk about requirements, our requirements to get our crew to the International Space Station, our safety requirements as well as our performance requirements. And so the first step of that was this certification products contract. And it was really part of a phased acquisition to get to that certified system. The primary objective of the CPC, as we like to call it, since we like acronyms, is to begin the early critical certification work to meet our set of requirements that we have laid out. It's really maturing key certification products in phase 1. That's what we're talking about in CPC. As those products get matured, then it brings industry and NASA all together to be ready to move into phase 2, which is the actual verification activity and then eventual certification of the system. We're very happy, and we did award these back in December 10th, and I'd like to congratulate the 3 companies that were awarded, Boeing, Sierra Nevada, and SpaceX. They were all awarded contracts for the certification products contract. Each of these is a fixed price contract, all for $10 million or less. There's really 2 sets of products that we will look for in this fixed price arrangement. The first set of products is the initial products of 4 different types I'll talk about here in a minute. And then we'll begin to have a number of technical interchanges with each of the companies to mature those products so they're ready for the final set of products as we move forward. From an overall cost standpoint for the taxpayer, we're going to pay about 40% of the total cost of the contracts in the initial products, which will be due here towards the late spring of 2013. And then we'll pay the rest when the final products are due towards the spring of 2014. This way we continue to work as a performance-based kind of arrangement where work is done. We look at the work, we talk with the partners about the work, and then based on the competency of that work, we then go ahead and will help make payment to our partners and our contractors. The next page talks a little bit more about the details of the certification products contract, in which there are 4 scope products. In the end, we want to get to the end of CPC with a certification plan. That's what we need. In order to get to that end state of a certification plan that both us and our partners can sign up to, we need to have the other 3 products developed and agreed to. Those are the alternate standards. We look at those as NASA has defined a series of standards we'd like them to use. In all of our standards, we say we are willing to talk about and figure out how you would like to meet that intent of those standards, because there's always more than one way to do a job. And we have noticed, as you can see from today's briefing, that each of these have come from very different approaches towards trying to create a capability. So we want to talk about those alternate standards with our contractor partners. We also want to talk about the hazard analysis. From a design standpoint, you design from what can hurt you, and then you design systems to mitigate what can hurt you, and that's called hazard analysis and hazard reports. And we'll work through iterations of those products as we work from the initial phase to the final phase. And finally, it's our verifications and our validation plan. Those verifications are the actual tests you're going to run, and all of our partners talk about the testing they're going to do in the next couple of years, which someday they may say we would like to use those tests as part of their overall verification effort. It will also include additional tests down to the component, tests at the subsystem level, tests at the system level, and tests at the complete vehicle level. And that's what our verification plan that we will work with each of the contractors with and buy into that. And all that comes together to meet a certification plan. That's the products we'll do under CPC. Once we are comfortable with those and our partner contractors are comfortable with that, then we're really ready to go into phase 2. And that's how we plan to approach phase 2. From a requirements, you also got to look at requirements variance process. And we have a number of requirements. All of you can read them online. There are about 300 of them that are our design requirements. There are performance requirements as well as our safety requirements. If you were to actually try to build a vehicle to every word and every I and every T in that requirement set, it probably would be extremely expensive, and it probably would never be able to get off the ground because of weight or power or whatever the issues might be. So what we want to do is we want to talk to each of these contractor partners about if there's anything we need to do to our requirements and variances to those requirements that look at risk. Really, variances are dealing with risk to the safety side, risk due to the cost side, and risk due to the performance side. And we want to look at all 3 of those components from a variance standpoint and talk to the partners and say, do you have other ways of meeting our requirements? Do you have other ways that say we can mitigate the risk, and therefore the requirement, the idea of the requirement is still the same, but the way we want to meet it, the way we want to try to deal with that requirement from a risk standpoint might be different. And we call those variances. And that is really very important that we encourage industry to look at different ways of doing business. As you can see from today's briefing by all 3 partners under ICAP and all 4 partners we have today, that they are looking at this very differently than anything that human spaceflight has done before. And that is good. They also are taking the experiences from human spaceflight that NASA brings to the table and that their teams bring to the table to show that it isn't a new sheet of paper. It's a sheet of paper that has history behind it to see what is good and what is bad about our past and try to improve on that. And that's what we encourage our partners to bring forward in these variances as we move forward. All right, so that's CPC, and that will start again January 22nd and goes until the spring of 2014. And then we talk about our next phase. And our next phase is what we call our certification phase 2. It will cover all aspects of the final development and certification of the crew transportation system. That is to include final design, final manufacturing capabilities, final testing, final qualification, final production and getting into that production, and actual operations. So that's a pretty big deal, and we need to make sure that we continue to partner with our industry partners to move forward so we're ready for phase 2. We intend to not do this, we intend for NASA, my team, not to do this in a vacuum and come up with a plan and roll it out and say, here's your plan, go try to meet it. We want to engage industry in how to evolve getting into phase 2. Because phase 2 is something very different than NASA has done before. It includes, we want to look at different ways of doing business. We want to finalize our plans and encourage involvement from industry. So we're going to be putting out a request for information, or an RFI, about certain questions that we'd like to get some feedback from industry on really within the next week. And we'll be looking for some feedback on that so that it helps us understand how we want to go into phase 2. Phase 2 will be a FAR-based contract, but that's a big picture. Now, how do you go do all the details of that is some of the questions you want to ask about. For example, what type of contract structure, what type of contract type? We have some questions we want to ask industry about and see what kind of feedback we get. We want to talk about how do we approach ISS missions. In the end, for the CPC and for phase 2, it's all about getting to ISS. And so we need to figure out how we incorporate ISS missions into that overall philosophy. And of course, we want to talk about FAA licensing. Because we're in a commercial environment, the idea is ISS is one destination, not the only destination. If that's the case, we need to talk about how we bring the FAA and regulatory agencies into practice with us so that there's an industry out there that isn't just for NASA. It's an industry that's really for the entire planet. And if they're launched out of the United States, then we think the FAA has a very important role in that. And so we have some questions about FAA licensing and how to go do that in enough detail to enter into phase 2. We're going to have a number of industry touch points. The next one will probably be after this RFI, will be in March of this year. Exact dates are still to be determined. And then we're going to come out with a draft RFP probably in the early summer to mid-summer timeframe. And that's really important to our industry partners here and anybody else in the industry who wants to participate so they can give us feedback on how we think we're going to go do this. And we'll take that feedback, see what is best from a government incorporation. Again, it's our request for proposal. And incorporate that into our final RFP, which should be coming out in early fall of 2013. The goal there is to have a contract awarded by May of 2014. So you can see that as we get through the base period of ICAP, as we get through CPC, we're now ready to move into this next phase of phase 2 with a contract award. So that's a lot of details about how we're trying to make the activity happen. Of course, a lot of that is based on the fact that there has to be an overall national initiative. And so this final chart I have is talking about how the Commercial Crew Program is really a national involvement. I think all of our partners talked about that. I like the passion that they each had towards trying to create a capability, not just for NASA, but also for the nation. It's a national initiative. It's not just here at Kennedy, although the program headquarters is here at Kennedy. It's not just at Johnson, where the deputy program manager is at, and also I have an awful lot of capability at Johnson that's helping the program. It's not just a NASA thing. It's really a national interest. It's a national human spaceflight activity for the nation. In fact, you can see from this chart that there's really 26 states that have activity dealing with the Commercial Crew Program today. Of those 26 states, there are 56 districts, 56 electoral districts that are a part of our activity that we're doing today. And there's 63 aerospace companies that are involved today. And that's really at the prime and the sub, and going down a little bit down the tier of subs and that kind of thing. Not every sub is listed in these 63 companies. But this shows that this is a national involvement. The Commercial Crew Program is not a single thing, it's a national interest. It's a national thing to get America having a capability to get back to low Earth orbit. That's what we're trying to do. That's what all these companies are trying to do. I applaud each of them for their very unique ways of doing that. My team is extremely energized by the activities that happened last year, and even more of the activities are going to happen this year. The team is we do a lot of travel, but I don't hear very many complaints about the travel we have to do because we're seeing growth in the American space flight industry. So that's where I'd like to end it, and I'll turn it back over to.
All right. Thank you, Ed. All right, we have a lot of folks lined up for questions today, so I'd like to please ask everyone to limit it to one question and a follow-up. Also, we have social media followers. If you have a question, you can ask your question on Twitter with the hashtag AskNASA. And we'll begin here in Florida. Please wait for the microphone, state your name and affiliation, and to whom you're asking your question. We'll start off with James.
Thank you. James Dean of Florida Today. Phil, I think budget has consistently been stated as the top program risk in its infancy. Now that you have the ICAP plans and milestones and costs all laid out, do you have a better handle now on what the actual costs are to get you to an operational flight by 2017? Can you just give us an update on what budget you anticipate needing after this year to stay on track, or is there still a risk of slipping if you don't get a significant bump from where you're at now?
Yeah, the budget is going to be an extremely challenging topic, I think, not only for this program, but for all NASA programs. I work up at NASA headquarters, and just a couple doors down from me is the director of the ISS program, and a couple more doors down is director of SLS and MPCV, and we all have the same issue, right? We all feel like we could use and need more money to go forward. But we're in a very constrained environment. We're going to have to get what we get. I think to answer your one question about our understanding of the cost, that gets better every month. Now that we have entered into ICAP and CPC, we are seeing a better understanding, a higher fidelity estimates of these crew transportation systems, and that will feed into our budget. We hope to have a budget come out fairly soon. Not sure exactly when that's going to be. The President's budget request for FY14 should be coming out within the next, I don't know when, but several weeks. And of course, there's a lot of activity in Washington, D.C. about that budget. So I can't really say about the budget, but I can say that we are getting smarter every day, as all our partners, about what we really think the costs are going to be. And that is an important factor.
And for the partners, Garrett identified a couple of flight tests coming up in the near term. Could you just, again, update us on your plans for any tests of that nature, or and ultimately, the first crewed flight test if budgets and schedules stay on the track? Yeah.
We, as I mentioned in my presentation, we are expecting to start our atmospheric flight tests here in the first quarter of 2013, and that will be the beginning of a flight test program regime that will continue on through this year and into next year, both autonomous as well as piloted.
Yeah, when you look at our plan, our plan would have first crewed flight in 2016. And when we went and laid out our CCICAP plan, it was very important to us that you follow the mantra of test like you fly and fly like you test. And for us, the big integrated tests such as pad abort, we decided that we needed to incorporate those in our qualification series so that it would be flight design hardware. The large-scale integrated tests, that's naturally where they would fit. And so those would be in our next phase following CDR, so that you can ensure that those larger tests would be done at the flight configuration. So those would be done early, but into the optional period, or phase 2.
Daryl Nail with Fox in Orlando.
Oh, I'm sorry, Daryl. Hang on. Did I cut you off?
Anybody else?
Okay. Okay, go ahead, Daryl.
This question to NASA, how many of the companies up here today will be commercially feasible as you see it, awarding contracts in 2014?
Well, I see all the companies here today are commercially viable as commercial spaceflight companies, no doubt in my mind. Now, who will be ready to compete for what we need in phase 2? I believe that you need to ask the companies. From a NASA standpoint, we believe that industry will be ready. We believe that there'll be more than one, probably 2, 3, maybe others that will be ready to compete for phase 2. But all 4 companies here today are capable and are the leading edge of what it takes to get folks back into low Earth orbit over time.
And a follow-up question to the partners. How does Russians flying American astronauts motivate your company or provide any type of motivation to what you're doing? I think SpaceX answered it.
I could not specifically about the Russians. The lack of a U.S. capability is something, obviously, that we're not happy about. I had Russian partners with me up on the space station, and the partnership is very strong on the ISS side. But I think to be a true partner in the space station, to be an equal partner, we need to come to the table with our own ability to get there, and we don't have that right now. And the fact that we're paying a lot of money, a lot of taxpayer money to the Russians to do that, I think it's $63 million a seat is what we're paying right now to fly U.S. astronauts up to the space station on the Soyuz. When we could be spending that money here in the U.S., yeah, that motivates us.
I think from our perspective, that was the original motivation for us getting into this, was that our belief was that we not only need a U.S. spaceflight program, but from our perspective that the idea of creating American jobs and American industry and moving forward, not just the hardware and the people, but the future of our children who are looking towards what they want to do with their future and how they want to educate. We believe that that's a strong motivation for what we wanted to accomplish. Our target was never other NASA programs or other programs in the United States. Our target was to repatriate that industry back here to the United States, and that's what we're doing.
Yeah, I'd reiterate, I think it's really emotionally and also strategically important that this country is a spacefaring nation, and we're excited to get back to that point.
I'll just add, I think ISS is a great example of international cooperation. So working with countries all over the world is a positive, but if we want to explore the frontier, we have to have a way to get there, and we've got to drive our own vehicle, so to speak. So having that capability for America and for several commercial companies is a real positive. So.
All right, we're going to go to the Johnson Space Center phone bridge now for questions and begin with Irene Klotz. Irene, are you there?
Yes, I'm here. Can you hear me all right?
Yeah, we hear you fine, Irene. Go ahead.
Thanks very much. I have three quick questions. The first for Ed Mango, do you anticipate multiple awards for the phase 2 of the program with flight tests? And for Garrett, if you could give us any update on the root cause of the Falcon 9 engine out. And for Mr. Meyerson, do you see any future on-road back to NASA funding for your company's efforts? Thank you.
See, I think I was first on there. Competition is key for anything that we do in the United States. That's how you get the best price. That's how you get the most innovation. So to answer your question, I very much want more than one company involved in phase 2 because I think it's that competition and that innovation that helps drive all of industry in the right direction and as quickly and as safely as possible.
I guess that was part B, the engine thing? Okay. So we did have an engine anomaly on the last Falcon 9 flight. We had to shut down one of the 9 engines in the first stage. And right after the flight, we convened an investigation group to look at this in-flight anomaly. And that group consisted not only of SpaceX engineers, but also NASA engineers. It was a NASA mission, and so we had NASA participation on the investigation team. That team has worked really, really hard at looking at all the data. We had tons of data. All the sensors kept working after the anomaly occurred, so we had a real plethora of data to sort through, and NASA helped us out with that. And we've gotten to root cause, and we briefed that just before the holidays to our customer, which is Mr. Suffredini, the ISS program manager, and to Bill Gerstenmaier at the head of human spaceflight at NASA. And we're right now we're just making sure that they're happy that all of our I's are dotted and T's are crossed, but we do intend to make that information more widely disseminated very, very soon. So I'm sorry I'm leaving you with a bit of a cliffhanger, but I promise you we're going to get you more information on that soon.
And the third question was whether there's a future on-ramp for NASA funding in the future for a company like Blue Origin. I believe there is. I think during CCDEV2 and CCDEV1, we proved that we're a very innovative company that can provide a lot of value to the government. I think Ed and Phil have seen that firsthand, and the Commercial Crew team. Whether it's with Commercial Crew or other programs within NASA, we always are looking for activities where we can work with the government and help us to accelerate what we're trying to do commercially, and we'll continue to do that. So. I'm optimistic.
Okay, back to the phone bridge, and we have questions, I believe, from Alan Boyle from NBC. Alan?
Hi, can you hear me?
We hear you.
Okay, great. I was hoping to get more details from SpaceX and Garrett about the plans to fly, I think you said, a non-NASA crew by the end of 2015. Could you lay out what that plan would entail? Are these people who would be buying flights, or if you could provide a little more detail, I'd appreciate it.
Sure, I'd be happy to. That is part of our optional. So CCICAP has a base period, but we're also asked to produce a bunch of optional milestones. So all of us, all the partners up here, went ahead and submitted a proposal that was assigned into a Space Act agreement that contained not only up to May 2014, but what we would do beyond that, getting all the way to the point of flying people to the space station. And so we laid out a plan with those milestones that gets us to flying the first test flight in the middle of 2015, and then flying to the space station at the end of 2015. That would be done with a test pilot crew. We were told that because this would be part of the development and prior to final certification, that we were not allowed to legally to use NASA astronauts to be part of that test pilot crew. So SpaceX, we're going to have company test pilots that would fly those missions, but it would be a minimum crew for these test flights. It would not be. We're not selling tickets. Don't call our toll-free number. Those are going to be test flights as part of the final development and test and certification process.
Alan, did you have a follow-up?
No, go ahead.
Alan, did you have a follow-up?
No, I didn't. Go ahead.
Thank you. Frank Mooring from Aviation Week.
Thank you. I have a two-part question. The first part for the NASA guys. Can you give me a sort of total figure for the percentage of support that NASA has given to the development of these three vehicles, I'll say, versus the amount of private funds that have gone in there? And then for the company guys, if you could say whether, given the tight budget environment that we're seeing here in Washington, whether or how much your companies would be able to take up any slack in case the roughly $850 million a year isn't forthcoming from Congress. Thank you.
Yeah, Frank, generally that is proprietary information. It's fairly sensitive how much the companies are putting in, so we don't publicize the percentage that the partners have contributed. We haven't in the past, and we're going to continue to maintain that policy going forward.
But I would add, not from a percentage standpoint, but every dollar that a company puts on the table in this partnership is one less dollar that the taxpayers need to put on the table. So, I'm not going to jump up and down about percentages as much as I would say the fact that it's a partnership and we both bring money to the table allows the taxpayer to get more for their dollar and allows the company to get more for their dollar. And that's what the partnership's all about.
Yeah, that really does provide what we've called skin in the game, and it is a key aspect of the partnership. Again, the percentage is interesting, but it's not. It's more of what the money represents. It represents a commitment on the part of the companies to bring forward some of their own financial resources for the development of these vehicles, and that is critical because we don't anticipate maintaining ownership of these vehicles. The companies are going to maintain the intellectual property, and they're going to own and operate these systems, and we think it's appropriate in that kind of situation for them to bring money to the table, which all of them are doing in pretty substantial fashion, even though we don't quote percentages.
And let's see, the second part of your question, Frank, I think asked about whether we companies would be willing to commit more if the NASA funding was lower than the $850 million request or plan. You know, I'd say, you know, when we look at our plan, I think we've put together a robust but affordable and aggressive. And whether the company really could contribute more, I think you have to wait and look at the true market assessment at that time and see how much the market has matured, and then look at the ability of your company to invest more and whether you could get a return. So I think you just really have to wait and look at the market emerging at that point.
I think from our perspective, we are contributing significantly to the program, and one of the things that a reduced budget would do is affect schedule, probably for all of us. And schedule is highly important here because we are targeting to get the most utilization out of the ISS as possible. So I think that the downside of this would be that while the program might maintain itself and we can continue to do the work that we're doing, it might take longer to get there. And that's going to have an effect on the really valuable work that's being done on the station.
So just to follow up, I guess this is kind of the same thing. To try to speculate about what would happen should funding be less or you know, different things occur with the federal budget. You know, life is vexing enough without entertaining hypotheticals. So I don't want to go out on a limb and try to cover all the possible permutations of what might happen. But I could tell you that SpaceX, like I said, human spaceflight is our reason for being. We are in this for the long haul. There will be impacts to cost and schedule. It should funding dry up, but you know, we're going to get there eventually.
Okay, next up is Dan Leone from Space News.
Hi, question for Ray at Blue Origin. Ray, would Blue Origin be interested in trying to get a CPC Phase 2 contract? Because those, I've been told very clearly, those are full and open competition, and that anybody who has a space transportation system that meets the requirements is welcome to apply. And of those who haven't gotten one already, I would hazard that if Blue Origin probably the furthest along. Is that work that the company is interested in, or would you give that a pass?
I can't really say until I see the draft RFP, and that hasn't come out yet. So what I know about it is what I've seen today. So it's a little too early to say, Dan.
Any follow-up, Dan? Okay, let's move on to Mark Matthews from the Orlando Sentinel. Mark?
Hey, guys, can you hear me?
Yes, we hear you, Mark.
All right, this question's for John, similar to the one that was posed to Garrett a little bit earlier today. Talking about that 2016 test flight, would this also be a non-NASA crew? Would it be a NASA crew? What type of crew size are we looking at? Where would it go? Can I get some more details about what you guys are planning there? Thanks.
Yeah, sure. Part of the requirements of CCICAP was to culminate with a crewed flight test that had non-NASA crew. So like Garrett, we have a crewed flight test planned. Ours is in 2016 with Boeing crew. There would be a 3-day flight demonstration test.
Okay. Next on the line is Tariq Malik from Space.com. Tariq?
Thank you. I also had a crew-related question for these new spacecraft. I'm just curious if each of the members of the panel could give us just a glimpse into your test pilot selection process. Do you have test pilots on staff? Garrett, I would imagine you'd be on that list for SpaceX. How are you training and merging that with the experience that you get from the astronauts that you work with as well? Thank you.
Well, I'll start. I mean, we have 2 former NASA astronauts on staff, and they help us in a lot of different areas, bring a very unique perspective. But I think the incremental development starting with suborbital allows you to really approach this in a different way in terms of training your flight crew and in a space-like environment, but not a fully orbital environment. And not unlike what NASA does with high-performance aircraft. So this is an approach we'll take through our development and preparation for orbital flight.
Sure. And one of our key acquisitions was Chris Ferguson, who was the last space shuttle commander. So he is on our team and responsible for crew and mission operations. And he is defining, not only the crew requirements but also the selection process.
From our perspective, our flight program is being run by Steve Lindsay. Steve is a 5-time shuttle pilot and former chief of the astronaut office. And because our vehicle is a lifting body piloted vehicle that has very direct similarities to the shuttle, there is a significant pool of people who have experience in that regard that we can draw on.
And at SpaceX, we're just starting internal discussions about how we're going to select crews for those first couple flights. So I don't have a definite answer for you, but I can tell you that since you made it personal, I did not come to SpaceX specifically with the number one priority of going back into space. If that was my number one goal, I would have stayed at NASA in the astronaut office and had opportunity to fly again to the space station. So what's important to me is not that I get to be the guy that flies on this vehicle. What's important to me is that I can look myself in the mirror, look at my wife and my son, and say to them that the risk is acceptable for me to fly. So that it's not important that I go, but I have to be willing to go, because I'm not strapping somebody else into it if I'm not willing to strap into it myself.
If I could add, though, I think everyone here, if I know the people that come to work at commercial space companies, I think there's probably no shortage of people that'll want to sign up and fly on any of our vehicles in those early flights. So.
Okay, next online, and I apologize if I get your name wrong, but is it Veronique LaCapra from NPR? Sounds like somebody is not muted on the phone bridge. Veronique, are you there? Okay, let's move on to Ed Grausberg from Flight International. Ed?
Okay.
How about,
sorry, no questions at this time.
Okay, I'm sorry, who was that?
This is Veronique, and I have no questions at this time. Thank you.
Okay, thank you, Veronique. How about Ed Grausberg from Flight International?
There's no Ed, but there is a Zach. I have no questions at this time.
Oh, okay, Zach, welcome. Go ahead. Oh, no questions? Okay. Michael Belfari from Popular Mechanics. How about Ken Kramer?
Hi, thank you. Yes, I'm here. First, good luck to everyone in getting American astronauts back in space as soon as possible. I have two quick questions for Mark and for Garrett. Garrett, please, can you tell us, you talked a little bit about resolving the engine problem, hopefully. Are you aiming for a March 1st flight of the next mission, or what is the target? And for Mark Sarangelo, talk a little bit more about that flight test article, what that would involve. Do you intend to launch that on an Atlas, and how close would it be to the actual vehicle? Thank you.
So yes, I'll go ahead first and say, as far as our next launch of the Cargo Dragon to the space station, yes, it's on schedule for an early March launch here out of Cape Canaveral, and we don't see right now any issues that would hold that up.
Thanks for the question. Our flight test vehicle is a full-size vehicle. The outer mold line in the perimeter of the vehicle is exactly what we would be sending to orbit. It's not outfitted for orbital flight. It is outfitted for atmospheric flight test. And the best way to provide analogy, it's very similar to what NASA did in the shuttle program with the Enterprise, creating a vehicle that would allow it to do significant flight tests whose design then would filter into the final vehicle for orbital flight.
Ken, anything else?
Oh, well, I could ask a Boeing a question if there is time. How close are you actually to cutting metal? And for Ed Mango, why are NASA astronauts not allowed on these test flights? Thanks.
See, was the first question about when we're going to cut metal? Who was that to?
I think that was for Boeing. First
Okay.
question on when we're cut metal. I think our first piece of flight design hardware will be delivered to KSC in the old OPF-3 within 5 months.
See, your other question was about NASA crew. And so at this point, what I'll say is under ICAP, if you remember a chart I had the two circles. One was public purpose, one was a NASA mission purpose. Under ICAP, that is really the transition, that is really mostly public purpose. And because we want our industry partners to develop a capability that they can use to go to destinations in low Earth orbit, we would like them to get to a point where they're ready to put their crew on their vehicle at their risk. And so it changes the dynamic a little bit when normally under a contract, the contractor comes forward and says he's ready to go fly, but it's a NASA individual that's going to sit on a rocket, so it becomes a NASA risk. What we did is we flipped it around under ICAP. It's not what we're going to do long-term under Phase 2, but we flipped that around under ICAP and said, we want to know when you're ready to fly your crew and put your people at risk. And that then becomes something that we were able to evaluate under ICAP. So I would say also, I think Garrett said it very well, in the end, all of our partners want to fly safe. They're not going to take any shortcuts on flying safe. They are going to try to figure out how to go do that the best way they can. And so all of us have the same initiative, and it doesn't matter who's sitting on top of the vehicle. It's a person, and that person needs to fly safely and get back home to their family. So that's the mission of all our folks on this panel and all of our industry partners, is to figure out how to get someone to fly. It doesn't matter if they're wearing a blue suit or a company suit, how they get back to landing and go back to see their family.
Okay, and I believe we have one more on the phone bridge from Eric Good. Eric, are you there? Eric? Okay, well, we're back here. Before we pick up any follow-up questions, we do have one that we received via Twitter on Ask NASA, and it's from Pat Host with Defense Daily. What are the specific safety requirements and standards that have to be reached for certification?
Well, let's see, this is Ed Mango. How I'd answer that is if you look at our web page, and we can get you that afterwards, it has all of our requirements listed. There's roughly about 300 of them. They are our safety requirements. Examples would be we have to be able to fly with a fault tolerance scenario that says if you were to lose a particular system, you have a backup system in order to get the crew through the rest of the mission safely. That would be the kind of requirements we have. Another one would be that during an abort, we have to be able to get the crew back to the surface safely. I think in the video that Sierra Nevada showed, they said no black zones. That's what we like to call it, I guess, in vernacular. But in reality, it's want to make sure that we can get the crew back to the surface and survive that all the way down to the surface on any abort scenario. We also have other performance requirements, which is we need to get the ISS for our mission. We need to provide 4 crew to the International Space Station. The vehicle needs to be docked to the International Space Station for up to 210 days and be able to leave at any time in order to get back home, either for an emergency to get back home or at the end of that particular mission. So those are the kind of requirements. Now, again, there's a couple hundred of them, and you can go online and get all those at our website. And all those have been defined, they've all been baselined. All the companies have them. They've had them since August. And so everyone is working towards the same set of requirements, and we don't expect to change them. We went through a great extent of trying to make sure we understood them, and we gave them out to industry, and now we're moving forward. And so that's what we expect the companies to try to meet. And when they have a better way of doing it, then they'll bring forward their variances, and we'll talk about those.
Okay, and we also just received a Twitter question from Alan Boyle from NBC, who was with us on the phone bridge. He wants to know, does Sierra Nevada have a crewed flight plan? They're planning suborbital flights first, ?
Yes, we do. Our vehicle is what we like to call optionally piloted, which means it's fully autonomous and fully piloted from its design. And so too does the flight test program. alternate between autonomous flights and crewed flights, and we will be going through the suborbital regime to get to orbital flight, and we will be doing that in both autonomous as well as crewed versions.
Okay, thank you. All right, we're back here at Kennedy. Do we have any follow-up questions? Seeing none, I want to thank you all very much and turn it over to Mr. Mango for some closing remarks.
Okay, thanks. And I definitely want to thank everyone for coming out to Florida. It's probably the warmest day I've ever seen in January, so thanks for coming to Chamber of Commerce Florida Day. I would say that the couple questions about crews and who they are, and I think I tried to answer that earlier about to us it does matter who's on top of the vehicle for a particular mission. When we're in our test flight phase, whether it's under ICAP, it will be crews from the companies. Under phase 2, it will be probably a combined crews between what NASA needs as well as what the company might want to do, and we'll have to go talk about all those details. But in the end, this is a joint effort between our astronaut corps and the astronauts or the crew members that the individual companies might be hiring. And it's that joint test plan that would get us to an end state. It isn't just one or the other. If anyone has developed aircraft in the past, you know that it's military pilots as well as pilots from the companies that do the flight testing. And so we expect that same kind of approach as we move through this overall process of trying to get developed. I'd also say it is important to talk about those blue suiters or company pilots that are flying the vehicles. But I would also say, just like in STS-1 in 1981, there were 2 pilots flying that vehicle, 2 test pilots. They took an awful lot of risk on that particular mission, but there were thousands, if not tens of thousands, of people behind there to make sure the vehicle was going to fly safe and the first test flight was going to be successful. It's no different than in this generation of human spaceflight endeavor that we're proceeding with. There'll be a couple people that are sitting on top of the vehicle, ready to fly the vehicle, but there'll be hundreds, if not thousands of people that are engineers, technicians, mechanics, quality folks that are behind the 2 people or 4 people that are sitting on top of the vehicle to go fly, that are going to make sure that the vehicle is as safe as possible to go fly. That is an American endeavor. That is a national interest. That is a national involvement to go make this happen. It's not just about the 2. It's about the hundreds of people that want to see America get back into space and have a transportation system to do so to low Earth orbit. Thanks for coming today, and thanks for listening. And y'all have a good day.
All right, thank you. And a reminder, you can stay up to date on the exciting progress of the Commercial Crew Program in several ways. On the web at www.nasa.gov/commercialcrew, on Twitter @commercialcrew, and on Facebook @NASA Commercial Crew. Thank you once again, and have a great day.
Good morning from Mission Control Houston, and welcome to today's International Space Station update. You're joining us now inside of the flight control room here at the Johnson Space Center in Houston, Texas, looking down as the Orbit 2 team is manning their consoles, monitoring all these systems on board the International Space Station. Today's team is once again being led by veteran flight director Paul Dye. You can see there in the light gray vest. All the teams here in Mission Control today following a dress code paying homage to one of the great flight directors in NASA history, Gene Kranz. Beside him is Capcom David St. Jacques, serving as the communication link between all of our teams here on the ground and the astronauts up in space, and he'll continue to serve throughout this Orbit 2 time period. And then meanwhile, our astronauts on board are the crew of Expedition 34, and they're being led by NASA astronaut Kevin Ford, currently on his second flight into space. He's there in the front row on the left. Behind him, 2 Russian cosmonauts, Oleg Novitsky and Evgeny Tarokhin, the 2 rookie space flyers on their first flight into space. And over there on the right, rounding out this 6-man crew, is another Russian cosmonaut, Roman Romanenko, Canadian Space Agency astronaut Chris Hadfield there in the front, and finally all the way on the right there, second NASA astronaut Tom Marshburn. Pretty busy day for these astronauts on board the International Space Station today. A couple of maintenance activities and also quite a bit of robotics activity taking place on board. Starting off with Commander Kevin Ford, who a little bit earlier this morning was doing some in-flight maintenance. He was going through the U.S. laboratory on board the station and inspecting some of the windows throughout. Following that, he moved on to doing an ozone sensor check inside of the Biolab glove box before moving off to his major activity today, and that's going to be focusing on the station's robotic arm. He and his fellow crew members reviewed all of the DUG and robotics procedures. DUG is the interface used to receive and display real-time station arm joint angle telemetry onto a laptop on board the station. And following all that review, which they just completed a short while ago, they'll be doing a walk-off and getting their hands on for the first time to maneuver that robotic arm around. Moving on, our Russian cosmonaut Oleg Novitsky was continuing some work he was doing yesterday inside of the Russian service module, also known as Zvezda. He's been doing a few repairs to the interior and installing some overlay plates. Following that, he took some time to participate in the Uragan experiment. It's an ongoing Russian investigation into developing more methods for natural and man-made disaster monitoring. So he was doing some observations of his own and quite a bit of photography. Another Russian cosmonaut, Evgeny Turelkin, meanwhile on board the station, was doing some routine maintenance on the comm subsystem throughout the Russian segment. He was assisted by by Novitsky throughout, and also teams on the ground. A little bit after that, he went on to participate in a study of the cardiovascular system under specifically graded loads. They were using the Velo on board the station. That's one of the stationary bicycles. It's located over in the Russian segment. Our third Russian cosmonaut, Roman Romanenko, was continuing some work on the plasma crystal experiment, which looks at small dust particles and other colloid-shaped particles suspended in fluids on board the International Space Station. He was also involved in some cargo operations, taking some items out of the 48 Progress vehicle currently docked to the Earth-facing side of the International Space Station. You can see the full station structure there with 2 Progress and 2 crewed Soyuz vehicles currently docked. So he was transferring a few items in and out of that vehicle before moving on to doing some routine maintenance on this Russian segment's Electron system, which helps generate some of the oxygen for the station atmosphere. Meanwhile, Canadian astronaut Chris Hadfield will be participating in all of those robotic arm operations today. Also doing another run of the InSpace 3 experiment this morning. InSpace 3 looking to obtain data on different fluids containing ellipsoid-shaped particles that change the physical properties of the fluids that they're suspended in when subjected to varying strength of magnetic fields. And then just a little bit later this morning, he'll be participating in a public affairs event, talking to Canadian media across that country. That'll be immediately following today's ISS update at 11:15 a.m. Central Time, 12:15 p.m. Eastern. And our final Expedition 34 crew member, Tom Marshburn, spent a few hours today inside of the Quest airlock working on some of the EVA or extravehicular activity tools. He was doing some maintenance to the PGT, or the pistol grip tool, which is more or less the drill that these astronauts use when they're outside of the station. You can see Marshburn inside of Quest doing some maintenance on that pistol grip tool right here. Aside from that work today, he'll also be joining Chris Hadfield and Commander Ford in all of their robotics activities, getting a chance to get his hands on that robotic arm. You can see it here as they do some walk-offs and have finished reviewing all of their DUG procedures and robotics methods. Good morning from Mission Control Houston, and welcome inside of the International Space Station Flight Control Room for this Friday's edition of ISS Update. You're looking down as the Orbit 2 team is manning their consoles, monitoring all of the systems on board this orbiting laboratory. That team being led for the final time in his career today by veteran flight director Paul Dye there, wrapping up an over 15-year career as a flight director. Started off on STS-63 back in 1995, and today will be his final shift as a flight director for the human spaceflight program. Joining him at the Capcom position there will be Anna Fisher, serving as the communication link between all of our teams here down on the ground and our astronauts up in space. Those astronauts right now engaged in a number of experiments are the crew of Expedition 34. They're being led by NASA astronaut Kevin Ford there in the front row on the left. This is his second flight into space. Immediately behind him are the Russian cosmonauts that flew with him on his Soyuz craft back in October to the station, Oleg Novitsky and Evgeny Tarelkin. Over there on the right side are our three newest crew members on board the International Space Station, arriving back in December. They are Russian cosmonaut Roman Romanenko, Canadian Space Agency astronaut Chris Hadfield there in the front row on the right. Finally, all the way on the right there, a second NASA astronaut rounding out this six-man crew, Tom Marshburn. So a week that started off with the holiday is filled up quickly for these Expedition 34 astronauts. Starting off on Monday, Commander Kevin Ford was checking out a few relief valves in one of the clean bench experiment facilities in the Japanese Kibo module. Also holding a conference that day with a future crew member, NASA astronaut Chris Cassidy. While he was working on that, our three Russian cosmonauts, Novitsky, Tarelkin, and Romanenko, enjoyed an off-duty day as they were celebrating the Russian Christmas holiday. Meanwhile, Chris Hadfield and Tom Marshburn were busy collecting biological samples for the ongoing human research facility. Those samples include things like blood, urine, and saliva that these astronauts collect and then store in any number of cryogenic freezers on board the station. They were working with the Melfi, or the minus 80 degrees laboratory freezer. Aside from that, they were doing some periodic health status checks and also reaction self-tests. Moving on to Tuesday, Commander Ford was doing his own biological experiments and body monitoring. He was doing a monthly periodic fitness evaluation on the station's CVIS, which is one of the stationary cycles used for exercise on board. Aside from that, he was gathering up some hardware for some work he'd be doing the following day inside of the combustion integrated rack. Meanwhile, Russian cosmonaut Oleg Novitsky was emptying what's known as the soft tank over in the Russian segment, also doing a few cable running operations inside of the Russian Zvezda service module for upcoming multi-purpose laboratory module integration. Fellow Russian cosmonaut Evgeny Tarelkin was doing some maintenance activity throughout the Russian segment on Tuesday, cleaning some of the panel vent screens and replacing the dust filters throughout the Russian segment's air revitalization system. He was also doing some routine replacement work inside of the Russian toilets. Meanwhile, Roman Romanenko started up the plasma crystal experiment, which would be run throughout this week. That is a fairly complex look at the study of the growth of plasma dust structures in microgravity, hoping to look at how the particle clouds behave and their internal flow structure and plasma dust crystals are affected during trips into space. Also, alongside with Evgeny Tarelkin, he was busy making a documentary about life on board the International Space Station. Meanwhile, again on Tuesday, Chris Hadfield was collecting a few more biological samples for that human research facility and also running his first instance of the In-Space 3 experiment, which would also be run throughout this week. In-Space standing for investigating the structure of paramagnetic aggregates from colloidal emulsions. It's looking to obtain data on different fluids containing ellipsoid-shaped particles that then change the physical properties of the fluids they're suspended in response to varying magnetic fields. Sixth crew member Tom Marshburn was doing some work for the environmental health system, setting up acoustic dosimeters, which look to monitor sound loads throughout the station to make sure they're acceptable for crew health, also working inside of the internal thermal control system on Tuesday. Moving on to Wednesday, Commander Ford was busy inside the Biolab glove box, changing out some of the gloves inside. He was also back in that on Thursday as he was doing an ozone sensor check. Aside from that, he was also working on the combustion integrated rack. He was removing the multi-user droplet combustion apparatus, doing a few hardware replacement works on that. Meanwhile, Oleg Novitsky was busy with the Russian bar experiment alongside Evgeny Tarelkin that looks to develop different selection and testing methods for detecting any depressurization on board the International Space Station. Aside from that, he was working on some maintenance ops inside of the Russian Zvezda service module, replacing some of the overlay panels on the interior. Meanwhile, Evgeny Turelkin assisted Novitsky with that bar experiment and those overlay panels, and was also on photography duty for that plasma crystal experiment, which was then being run by his fellow Russian cosmonaut Roman Romanenko, who again will be running that experiment throughout the week. Aside from that plasma crystal, Romanenko on Wednesday was inside of the 49 Progress cargo vehicle, taking some of the cargo out and loading in a number of different trash items. You can see the station structure and makeup right here. Currently 2 unmanned cargo Progress vehicles docked, alongside with the 2 Soyuz craft that carried these 6 astronauts to their home on board the station. Meanwhile, on Wednesday, Chris Hadfield was working inside of the water hygiene compartment. He was doing some annual overhaul performance work. He was replacing a number of items inside of the WHC that are used to process urine. He was in there taking out the urine valve block and a number of the lines and pressure sensors, and also replacing the flush water tank empty pressure sensor. You can see Hadfield working here again. This taking place on Wednesday inside that water hygiene compartment, doing some annual replacement work. Aside from that maintenance activity on Wednesday, Hadfield was also conducting the reversible figures experiment, which looks to investigate how microgravity affects these astronauts' perception of various ambiguous figures. Our 6th crew member on Wednesday, Tom Marshburn, was recharging and setting up a few more acoustic dosimeters for the environmental health system, and also getting his first shot at running the capillary flow experiment. This is a fluid physics experiment on board the International Space Station that looks to investigate how fluids move up surfaces in microgravity. The results are hoping to improve any computer models that are used down here on the Earth by future spacecraft designers as they continue to develop new low-gravity and microgravity fluid systems, hoping to improve on all fluid transfer systems for both water and fuel on future spacecrafts. Moving on to Thursday, Commander Kevin Ford back inside that Biolab glove box doing a check on the ozone sensor inside, and you can see that Biolab glove box here. It's used for conducting a number of different biological experiments inside of the station's Columbus module with various microorganisms, fungi, and also small invertebrates having been flown to the station. They are then able to subject them to various conditions, also a centrifuge inside to simulate gravity and compare the 2 results side by side, also allowing these astronauts to not only expose different microorganisms and biological samples to microgravity, but also the radiation experienced in space. Aside from that, he was busy most of the day alongside his fellow USOS crew members Hadfield and Marshburn as they were manipulating the station's robotic arm, also known as Canadarm2. Ford was inside the cupola, and the 3 astronauts reviewed all of the safety and procedural items before each getting a chance to get their hands on the controls and perform a walk-off of the robotic arm. And while they were doing that, Oleg Novitsky was inside of the Russian service module finishing up some work on those overlay plates. It was the 2nd day of that. Following that, he moved on to the Uragan experiment, which is an ongoing Russian monitoring project to observe and photograph both natural and man-made disasters and hopefully assist in any responses down on the ground. Meanwhile, Evgeny Turelkin was doing comm subsystem maintenance work alongside. He was assisted by Novitsky. And also, a little bit later in the day, Turelkin was doing a Russian biological experiment looking at the cardiovascular system as he exposed himself to various physical loads while on the Velo, which is the Russian version of the Sevis, one of the stationary bicycles on board the station. Roman Romanenko on Thursday was inside of the 48 Progress, having previously been inside the 49 Progress vehicle, doing some more cargo operations and updating the station's inventory management system. Aside from that, he was working on the station's Electron, which is one of 2 oxygen generating devices on board, which derives oxygen from water and then pumps it into the station's atmosphere, giving these astronauts a safe breathing environment. Meanwhile, Chris Hadfield was conducting another run of that In-Space 3 experiment and also participating in that robotic arm control activity. Meanwhile, Tom Marshburn, aside from doing the robotic arm activity on Thursday, was inside of the station's Quest airlock. You can see him here surrounded by the EMUs, or extravehicular mobility units, that these astronauts will wear. U.S. astronauts and some international partner astronauts will wear whenever they conduct spacewalks on board the station. He was inside of that Quest airlock doing some maintenance on the pistol grip tool, which you can see in his hand there. It's the multi-purpose drill and ratchet tool used by these astronauts when working on the external station structure for all of their spacewalks. And all of that leads into today, Friday, the end of the week for these Expedition 34 astronauts. Kevin Ford began his day working on the SLAMmed, or the Space Linear Acceleration Mass Measurement Device. It's a device using known forces and in order to measure the astronauts' body mass, as they can't just step on a scale due to that lack of gravity. Aside from that, he'll be spending a lot of his time today, including right now, working on the Spheres project. The Spheres Zero Robotics is an ongoing competition of over 20 teams of high school students who are gathered at MIT today. Students develop different algorithms for maneuvering these small bowling ball sized satellites throughout the microgravity environment of the International Space Station. So he'll be assisted by that by Tom Marshburn throughout the day today as they run through the competition and are currently talking with the students and the organizers at MIT up in Massachusetts. Meanwhile, Oleg Novitsky is continuing his work with the Uragan experiment, that man-made natural disaster monitoring set up on board the station. Also running another session of the BAR experiment alongside with Yevgeny Turelkin, looking at different methods for identifying depressurization on board the station. Aside from that, Turelkin will be photographing a number of the windows throughout the Russian segment, as they are always checking the quality of these throughout their space flights. The third Russian cosmonaut, Roman Romanenko, will be conducting one more run of that plasma crystal experiment before getting into a couple of maintenance activities over in the Russian segment. Meanwhile, Chris Hadfield running one more instance of the In-Space 3 experiment, and also taking a few samples from the internal thermal control system on board the International Space Station. And then our final crew member today, Tom Marshburn, working with those spheres, and also a little bit earlier this morning participating in another run of the reversible figures experiment and setting up a few more acoustic dosimeters. So joining me here now in Mission Control Houston, it's a real privilege. I have our veteran flight director and our flight director for Orbit 2 for the week, Mr. Paul Dye. This is his final week as a flight director here at NASA. Paul, first off, I really want to thank you coming on and talking to me for a little bit, sharing all your experiences with me today.
Sure, Dan. It's great.
So I want to jump right in. How has this last week felt? I mean, you're a flight director, you're a very integral part of the human space flight program. How has this last week felt so far?
Well, it's actually been quite fun. You know, I was afraid that it was going to be a little bit sadder than it has been, but the truth is that I've been very, very privileged to fly spacecraft for the United States for many, many years, and flew the entire shuttle program, and now finishing up with the station, and I did station as well, but finishing up dedicated to station the past year and a half has really been fun, because I've been able to work with a lot of young folks and pass on a lot of things that were passed on to me by the early Apollo veterans. And so the week hasn't been as sad as I thought it might be. It's actually been a lot of fun to just to work with the flight controllers again.
And we've been keeping it pretty light. We've been having the good, cool dress codes this week. As you can see, today was vest day. We had an Apollo day yesterday, which is really cool.
We had a white shirt and skinny black tie day yesterday, just to remind people of where we come from and think about the history.
And let's jump into your history really quick. Now, you started here as a student in the cooperative
That's
program.
right. I came here as a student from the University of Minnesota back in my, I guess it was my junior year of college, after my junior year of college, and didn't know what I was going to be doing. But it turned out that that the operations group had seen my resume, and I'd been flying. I was a commercial pilot when I was young, and I'd been in the diving business when I was young in college. And they said, "Hey, here's a guy who knows operations, real-time operations. Let's snap him up." And so I came here as a flight controller and worked on some of the very earliest shuttle missions, and moved on to being a senior flight controller pretty quickly, and then was a flight controller for about a dozen years before I was selected as a flight director in 1993.
And tell me a little bit about your experience as a flight controller. Now, when you are the flight director, you're overseeing every flight controller. You are the flight controller. You're the hive brain. That's
Right.
you.
Yeah.
How did your experience as just one of the flight controllers here in the room? How did that really help you get to where you were?
You know, there probably isn't any better leadership school than mission control here in the front room. And that's not just for flight directors, it's flight controllers as well, because every front room flight controller has a back room of flight controllers that supports them. And so you have to lead your back room. You have to learn to trust your back room, just as the flight director needs to learn to trust his front room flight controllers. You learn how the business works. When we get selected as a flight director, we're given basically a year of training. And people say, well, golly, you learn to be a flight controller, and and you learn to be a flight director in a year. And I said, no, I learned to be a flight director in 12 years as a flight controller, watching how flight directors worked and learning the spacecraft systems, not just learning the systems I was responsible for, but learning everybody else's systems. And that's what made me qualified, like other flight directors, to be a flight director. We were looking outside of our own responsibilities to really look at the big picture.
So really being part of a team and eventually leading the team.
You've got to be part of the team. I always joke around with flight controllers. It's not really a joke, but it's a thought experiment when I'm talking with Ficker front room flight controllers in training, and I tell them that sometime we're going to do a simulation where just before we start the sim, I'm going to make everybody in the room switch consoles. And the idea behind that thought experiment is to get them to think about what would terrify them the most, what console would terrify them the most. And I ask them that, and then I say, well, that's what you need to go study. I assume that if you've made it to the front room, you're already an expert on your own systems. What you need to learn is how to interface with everybody else. And that's what's really valuable.
Now let's jump right into, you made it as a flight director. Now your very first mission, STS-63. That was a hallmark mission, really, in U.S.-Russian relations. That was the space shuttle, did a fly around and a rendezvous with Mir. Nowadays, U.S. and Russian space agencies, that's an everyday thing.
Right.
What's it been like to really see the progression from that very first, big partnership step to where we are today?
Well, I'll tell you the story behind that was that I started working with the Russians before that in 1992. There was a meeting between our president and their president, and they decided that we needed to work together better, and they thought maybe the space programs could do that. And so our agency head met with their agency head, and they said, our president said we should do something together, so let's get some experts together. And a very small team of Americans, myself included, went over to Russia, and we sat across the table from our counterparts in Russia, and we said, well, our government said we should work together. What do you think we can do with each other in space? And they said, well, we have this space station, but we don't have a shuttle, and you guys have a shuttle, but you don't have a space station, so maybe we can go visit each other. And that's where it came from. And because I was working on that as a senior flight controller and got very deeply involved with that, it made me better prepared to be selected as a flight director. And lo and behold, I worked all of the Shuttle Mir missions. We had a very small team of people who worked all the Shuttle Mir missions, because the Russians really like working with particular people, not with a person with a title. But they want to work with Paul. Once they know Paul, they want to work with Paul. The relationship's important.
So you became their go-to.
That's right. And there was a small group of us that did that. So we worked a small group that did all those missions. And there was a lot of time where we had to discover how each was different, but we really discovered that we were very, very similar. And I told you that when we were sitting across the table, you could point at a guy and say, he looks like a ground controller. That guy looks like an instrumentation officer. And sure enough, that's what they were. That's just the way they worked is very similar to the way we work. And here today, when we work with them on a constant basis, we have Russians here and we have Americans over there, and we're constantly talking back and forth. We work very naturally together.
Okay, now let's jump to the end. You were a flight director on the final shuttle mission, STS-135.
Right.
Want to see if you can go back to that day. How much did it mean to you to really be part of that, flying it out, seeing the successful end of the space shuttle program?
I think that you have to understand that I'm basically an airplane guy. I grew up as a pilot and silk scarf and goggles and the like. And so to me, the space shuttle was the fastest flying airplane ever built. And there's nothing about the shuttle that I didn't like. I spent a lot of time flying it in the simulators, doing a lot of development work with the handling qualities and things like that. To see the program end was very tough because we could have kept flying that bird for a long time. I'm talking about from the standpoint of from engineering-wise and operations-wise, we could have kept flying that, and it would have been nice. Here we finished the station, and it would have been nice to be able to continue carrying large loads up and large loads back. And so that last shuttle mission was a little tough. But the great thing about it is that we flew it as professionals right to the very end. We had people that were working on console that knew they were walking out the door when we landed, and they never let up, not one iota, until it was done. That's how much they cared about the program.
And these teams always shown so much dedication, and it's always been very impressive. Now, before you were talking to me, flight directors think fast.
Right.
You describe that again, because that was very cool.
I think one of the hallmarks of flight directors, either by selection or by training, is that we tend to think very, very fast. We think of contingencies, and we think of multiple paths and multiple contingencies. And before we make a decision, we've probably gone very quickly through our mind of, if I do this, I can get this. If I do this, I go this. And if this happens, and this happens, and this happens. And that sometimes isn't apparent to other people. They just see us go, okay, we're going to do this. And then they ask us, well, have you thought about that? Have you thought about this? Have you thought? Yes, I've thought about all that stuff, and I know that this is what I want to do. And that's probably one of the hallmarks of most of the people who've sat in the center seat here.
So for all the flight controllers in this room that are maybe aspiring to someday become flight director and sit in your seat, what advice would you give them?
They've got to get outside of their own systems. They've got to think the big picture. They need to constantly be thinking about how they serve the overall mission. Our goal is two things, flight safety and mission success. We want to make sure everybody comes home, and we want to make sure we accomplish the mission. It doesn't do any good to accomplish the mission and people don't come home. So you got to do both those. And in order to do that, you've got to understand all the systems. You have to understand how they play together. You have to understand what the program wants and how the program needs to be accomplished. And today with a space station, you have to understand all of the international partners and how they contribute and how they work. It's a vast program, and you can't do it without a great deal of help. We sometimes describe flight directors as the conductor of an orchestra. I am not a virtuoso on every instrument. I may be able to make noise with most of the instruments, and one or two of them I can probably play fairly well. But we have to depend on a big team, and you have to learn leadership and how to develop leadership, what leadership is. It's different than management. Leadership is about inspiration. It's about inspiring people to a vision. I can identify a leader in an instant by saying, what's your vision? And if they don't have one, then I know that they're not a leader. You have a vision, you make it so attractive to other people that they say, I got to go do that. And the leader just needs to get out of their way and help provide them with the resources to get it done.
Well, hopefully we have a few more leaders sitting here listening in that are going to take note. Well, as your time as a flight director is coming to an end, is there anything you're really, really going to remember from all the time you spent in this room flying the shuttle? Is there anything that's really going to stand out?
You know, people ask me that all the time, and the fundamental answer is I have had so many incredible moments doing what I've been allowed to do for 33 years that it's impossible to pick them out. It would be like choosing between which is your favorite child. We've just had so many incredible moments from beginning to end, and sometimes you stop and you go, wow, I can't believe I've been allowed to do that. People who are really enamored by space and aeronautics and the like, but haven't been given a chance to work here, would probably give just about anything to have been involved in some minor way with one shuttle mission. I flew 39 missions as a shuttle flight director, 9 of those as the lead. How can I possibly complain about anything? Everyone was a highlight.
Well, it sounds like you certainly will be walking away with, just as much as you put in, I hope.
Oh yeah, it's been an incredible experience.
any big plans for afterwards? Anything exciting you're looking
Well,
forward to?
I've always been an airplane guy, and I'm going to continue being an airplane guy. I'm pretty deeply involved in experimental aviation, flying and building airplanes, and helping to test airplanes and work on designs. I'm an advisor with the Experimental Aircraft Association. I'm big into operations and safe flight testing and things like that. So we have a lot of things to work on in that area, and flying is wonderful.
All right. Well, best of luck with that. Stay safe in the air. You certainly have a lot of experience with flying safe, so I have no doubt you'll continue to carry that on.
Okay. Thank you very much.
Really want to thank you real quick, Paul, so much. It's been a real privilege. It's been great sitting here with you and the team for your last week, and it's been an honor.
Okay. Well, thanks much. We'll see you tomorrow.
Best of luck in the future.
Okay. Bye-bye.
All the companies here today are commercially viable as commercial spaceflight companies. No doubt in my mind.
Officials from NASA and the companies participating in the agency's Commercial Crew Program discussed the progress of CCP during a press briefing at the Kennedy Space Center.
I think the partnership between NASA and each of these companies clearly shows that we have a very vibrant space industry in the United States, and the space industry wants to meet the goal of getting U.S. capability back into low Earth orbit.
Through CCP, NASA is working with the Boeing Company, SpaceX, Sierra Nevada, and Blue Origin to develop safe, reliable, and cost-effective access to and from low Earth orbit for potential government and commercial customers. February 11th is the scheduled launch date for the Landsat Data Continuity mission from California's Vandenberg Air Force Base. LDCM will continue the Landsat program's 40-year tradition of monitoring Earth's landscapes from space.
The new instruments to be flown on this mission, the Operational Land Imager and the Thermal Infrared Sensor, are an evolutionary step in sensor design with improved capabilities over previous Landsat missions.
The 4 decades of data from Landsat constitutes the longest-running record of the Earth's continental surfaces as seen from space. Observations by LDCM, a collaboration between NASA and the U.S. Geological Survey, will lead to advances in a wide range of Earth sciences, the management of agriculture, water, and forestry, and serve as a valuable resource for education, business, and government. NASA is deploying the Airborne Tropical Tropopause Experiment, or ATREX, to study key climate change issues related to the moisture in and chemical composition of the upper atmosphere. NASA's remotely controlled long-range Global Hawk aircraft will take measurements in the Pacific Ocean's tropical tropopause, a layer of the atmosphere between 40,000 and 60,000 feet above sea level.
Our experiment is designed to look at processes that can affect global change, specifically the process of changes in the stratospheric water vapor, which we know can affect global change, which we know can affect the overall temperature of the surface.
New findings by NASA missions headlined the news at the 2013 meeting of the American Astronomical Society in Long Beach. Among them, the discovery by the Kepler spacecraft of 461 new planet candidates. 4 of the potential new planets are less than twice the size of Earth and orbit in their sun's habitable zone. That's the region where liquid water might exist on the surface of a system's orbiting planet. Since the last Kepler catalog was released last February, the number of candidates scientists have discovered in the Kepler data has increased 20% and now totals more than 2,700 potential planets orbiting more than 2,000 stars. Meanwhile, 2 new images from the X-ray eyes of NASA's Nuclear Spectroscopic Telescope Array, or NuSTAR. The first reveals the brilliant glow, seen in magenta, of 2 black holes lurking inside IC 342, a spiral galaxy 7 million light-years away, more than 10 times brighter than stellar mass black holes in our own galaxy. The brilliance of these ultraluminous X-ray sources, or ULXs, is a mystery astronomers believe NuSTAR can help solve. Also captured by NuSTAR, the first resolved image ever of the historical supernova remnant Cassiopeia A. Light from the stellar explosion that created Cassiopeia A took 11,000 years to reach Earth. While the star is long dead, its remains are still bursting with action. The outer blue ring is where the shock wave from the supernova blast is slamming into surrounding material, whipping particles up to within a fraction of a percent of the speed of light. New star observations should help solve the riddle of how these particles are accelerated to such high energies.
Hello, I am Justin Lin, Mobility Downlink for the Mars Science Laboratory mission, and this is your Curiosity rover report. Over the winter holidays, Curiosity was parked at a location dubbed Grandma's House at Yellowknife Bay. At this location, Curiosity took a series of images to create panoramas of the surrounding area. In addition, the team downloaded as much data as possible from Curiosity to free up the onboard data storage space to give her a fresh start to the new year. Once the new year approached, Curiosity was ready to spin her wheels and stretch her arm. She started off with a 3-meter drive to an interesting feature called Snake River. Over time, dust has accumulated on all the rocks, and it hides features such as fissures, inclusions, or pits that are of interest. At this location, the team selected a rock for the first time use of the dust removal tool. The tool has a set of spinning metallic brushes, and this allows for the features to be exposed for unobstructed APXS or ChemCam observations. While these activities are taking place, the team is searching for a suitable rock to test out the rotary percussive drill. This is a very exciting activity because it will be the first time that we will be drilling into a rock, acquire a sample from deep within the rock, and also sort and transport it to the science instruments on board Curiosity. This has been your Curiosity rover report. Please check back for more updates.
We have main engines up and running. 3, 2, 1. Booster ignition and liftoff of the Space Shuttle Atlantis on a 10-day mission to dock with Russia's orbiting outpost.
Following its launch from the Kennedy Space Center 16 years ago on January 12, 1997, Atlantis became the 5th space shuttle to dock with the Mir space station. During the 5 days of STS-81's docked operations, the shuttle and station crews transferred nearly 6,000 pounds of water, U.S. science equipment, and Russian logistical equipment from Atlantis to Mir. The 10-day mission brought home astronaut John Blaha after a 118-day stay aboard the Russian complex. Among the 7-person Atlantis crew was John Grunsfeld, now serving as head of NASA's Science Mission Directorate.
We have an image here in Mission Control.
And 7 years ago, on January 15, 2006, the return capsule from NASA's Stardust spacecraft landed in the Utah desert, completing its 2.9 billion-mile round-trip journey to collect dust samples from the tail of comet Wild 2. Research done on these particles revealed surprises, including the sample's closer resemblance to a meteorite from an asteroid than that of an ancient comet. Stardust is the first spacecraft to make it back to Earth with a comet's dust particles in tow. And that's This Week at NASA.